Okay, we are live, I think. Voice test 111. Okay, we are live, I think. Voice test 111. Okay, yeah, so today we're going to be using Haskell to solve die 6. ይህንን ዌብ ፔጅ ይሄ ላርኔክስ ኢንዋይ ሚኒትስ የሚል ዌብሳይት አለ so it just shows you like አጭር description of a language. If we say go to Rust, you'll see like a single page documentation of like the syntax and stuff you need to know about. Rust, for example. Yeah, I'm gonna open that for Haskell here. We'll be using that as a reference. This is the Haskell website. Documentation ምናምን ሊንክ ከዚህ ጋር እንፈልጋለን so let's just keep it here and then let's put advent of code here 3 ደቂቃ ይከፍል ይቀረዋል የዛሬው puzzle እስኪከፈት and then we're going to be down to a shoot somewhere. I don't know, I guess we went down the elevator and we're gonna get to some place. Yeah, and then I'm currently installing the Haskell language server, but it's taking ብዙ ጊዜ እየቆየ ነው. It's downloading 500 megabytes and we've downloaded 180 megabytes count, so where is OBS? Let me structure this. OBS should be at the end, this should be here, then this makes sense. Okay, hopefully in that now maybe Haskell playground online playground we will start writing it in an online playground, and then maybe we'll start writing the program here and then we'll copy it over because ቀድሜ like ከስትሪሙ በፊት ዳውንሎዱን ባስጀምረውም it's still way too large. I don't know, maybe Nix is actually messing up. Let's see how big the actual package is here. Oh, actually it's big, it's 200 megabytes here. Wow, I didn't know Haskell compiled binaries እንደዚህ ትልቅ እንደሆኑ. What the heck? Okay, 200 megabytes almost like it's around 200 megabytes for depends on what system you are on, but most of them it's 200 megabytes, but these are all x86 64. There is no, okay, there is one here and it's okay. I guess the ART64 build is 203. I don't think I'm seeing any macOS builds, but yeah, hopefully. Okay, 57 seconds, 55, 54, and then let's take a look at our leaderboard. Okay, so anonymous user 31304770 is number 1, and it's me, and then there's someone Hundera and David Mangusto, and then I think the list is growing. We're now up to 24 people, but I think today will be, even if we get stuck, we can spend more time on it because Saturday is on. I don't have የስራ commitments, so we can spend more time on it. If we get stuck, we can spend more time than 2 hours on this. ከሁለት ሰዓት በላይ ስትሪሙ ሊቆይ ይችላል. If we get stuck, hopefully we won't get stuck, but when we finish this, we'll be halfway through the puzzle, and then we're just gonna have another 6 left. Okay, day 6, trash compactor. After helping the elves in the kitchen, you are taking a break, helping them reenact a movie scene when you enthusiastically jump into the garbage chute. Whoa, why? Every 4 later you find yourself in a garbage smasher. Oh no, unfortunately the door has been magnetically sealed. As you try to find a way out, you are approached by a family of cephalopods. Cephalopods means, I think cephalopods is the parent group of octopuses. Yeah, these are like one of the coolest animals. This video by Joe Scott is really good. Cephalopods, aliens from Mars. It's really good. Yeah, cephalopods. Okay, they are pretty sure. They're pretty sure they can get the door open, but it will take some time. While you wait, they are curious if you can help the youngest cephalopod with her maths homework. Okay, cephalopod math doesn't look that different from normal math. The math worksheet, your puzzle input consists of a list of problems. Each problem has a group of numbers that need to be uh, be either added or multiplied together. Okay. However, the problems are arranged a little strangely. They seem to be presented next to each other in a very long horizontal list. For example, each problem's numbers are arranged vertically at the bottom of the problem is the symbol of the operations that need to be performed. Problems are separated by a full column of only spaces. The left and right alignment of numbers within each group can be ignored. Oh no, okay, so this is the kind of the annoying thing. I guess we can split by white space and then trim the we might need to I think we might need to split using a regex or and then we might need to or we can just split and then filter out split and filter okay yeah. Okay before problems are separated by a full column of only spaces, the left and right alignment of numbers within each. I guess we can only just split it, group it into three because we will know we don't have to split it by space. We know that it's going to have a width of three numbers. But okay, the alignment of numbers within each problem can be ignored. Um, so this worksheet contains four problems. To check their work, Cephalopod students are given the grand total, adding together all the answers. I guess this one is gonna be a parsing challenge. So I'm gonna get a look at the puzzle input. Oh, okay. Let me zoom out so that we can see it. Actually, it's I don't know if I'm seeing four-digit numbers here. We don't actually know. I don't think we actually know if it's going to be if it's going to be only 3 digits, if it's going to have a width of 3 digits. I'm seeing 4 digits as the max here, but we can just ignore that. So what we need to do is um, we're gonna have a grid of numbers. So it's gonna be something like the last one. So we're gonna split by new lines, and then everything except the last one is gonna follow some pattern, and then we're gonna create a grid out of this, and then we're gonna apply the multiplications and the the additions to that grid. Yeah, yeah, I think that's gonna be the case. But here, yeah, so it's taking 200 megabytes. So let's get started with just doing this ourselves. So we're gonna have data. Um, how should we structure this data? Should we just do a wake of um, data? Is gonna be a list of okay. So we have data op. I guess yeah. So operation mal or add, and then we have a data um, column, right? So this column is going to be a column with a operation and a list of ints. No, not save. Run. Something like this. List is not a type in Haskell. List. Maybe they call it Vic list type. Haskell. Oh, we have to import it, I guess. Import data list. I did see some data definitions in here. List is not a constructor, or we can say import and then maybe we have to import the list data list dot list, or maybe we have to do that. I guess it might be a namespacing issue. List dot list. Module. Oh, we need to define our own module. Okay, so let me copy this and let's go back to what we had earlier. Okay, we need to do, okay, so let me just do that. Then here you need to do a list. Is that how it goes? They are fully equivalent and list they will be normalized to okay. Oh, I think maybe that's how. This is maybe how you define an int. But let's do int first. Let's just see if that works. Something like that. Okay, that's how you define it, I guess. Main IO main do, I guess do then print star then, you know. I think you just do this. Should work. Auto playable declaration expected. Okay. It has to be double. Oh, put string then. Okay, we're halfway through the download, and then it's been like 4 and 10. Yeah, it's been like, I think maybe 20 minutes since I started this command, so I think we're gonna be forced to implement this function. But okay, so parse line. So what do we need to do? We just need to split it by spaces, and then we might get an element of that list with that has space in it, but for those we can just filter them out. So I'm gonna say I'm gonna create parse input line is gonna take a string and then it's gonna return a list of integers. Parse input line is gonna take a string, it's gonna do a string dot split. Maybe do they have a string dot split? Maybe there's a search here. Haskell string, update auto string, and then let's see if they have a split. Oh, they have a lines, so that's gonna be useful. They have a words. This is what we want. Breaks a string up into a list of words which were delimited by white space. So we're gonna do this. So string dot words, and then we can say list dot map, right? And then for each we can say they can maybe have a filter map. What kind of maps do they have? Do they have a flat map? They have a normal map. They have a concat map. They have a map accumulator. They have a group onlines. No, that's not what we want. Something that takes a maybe. Okay. Maybe. Look up. Nope. Find index. Nope. Head. Filter map. Oh, it's part of another package. Filter. Inefficient implementation of map. No, that's not what we want. Filter map list. Yeah, maybe. Map maybe. Where is map maybe? Map maybe. It's part of maybe. Okay. So that's maybe data dot maybe, and then map maybe. It's not what we want. What the heck? Okay, that doesn't take a list though. It takes a that's okay. That's what we want. It takes a function that will return a maybe, and then it takes a list, and then it will return the just the values in that maybe. So let me duplicate that. So what we need is so list dot map map dot map maybe, and then we need to parse a string to map maybe. So string to int Haskell read sternum. Oh, don't this return a read maybe. Haskell taketh read. No, Haskell taketh. Does not taketh. And then they have a read maybe in here, and then that it's regardless of the type. Read maybe. There is some, what was it, Google, that lets you search for functions, search for Haskell functions. Yeah, I think it's okay. Read maybe. So read maybe. This is read maybe. Read maybe takes in something that can be read, a string, and then whatever type you wanted it to be. So you have to specify. So it's okay. So we gotta define a to int, right? Maybe int, and then we have to use this read maybe. don't know if we need to do that because we specified it here. Yeah, and then here we can say map maybe to int, right? Split it to a new line. Okay. No. String. No, this is maybe, and then maybe map maybe. Okay. A string, no module string is imported. String. There it is. I guess this look at how Haskell. It reminds me of Elm importing, but Haskell importing. Do we have to say us and then string if we want to do dot access? Yeah, this imports everything. Okay, so we don't have to prefix them, but I want to be able to prefix them, so we have to say us list and us maybe, and then us string. Oh, read maybe is from text.read. Import text.read. Okay, and then saying suggest a variable not in scope. Oh, what piping? I need to import pipe. Suggested fix. We can say this doesn't really need to be. It can be something like this. Oh, we need to import a pipe operator. I thought it will be part of the prelude. Haskell pipe. We might need to do function composition and type. Forward pipe. Haskell composition. I guess in Haskell you don't do the pipes. One common implementation of a forward pipe in Haskell is we can do we can use function composition, but I feel like pipes are more readable. What did the error exactly say? Variable not in scope. I think we need to import it from something. I thought this should be part of the prelude, but okay, it's from data function. It's from data.function. 300 megabytes. Data function. Let's look for pipe. It's not there. It's not there. We can search for it on Noogle maybe. Noogle. No, Noogle. Yeah, I don't know. Yeah. Next version of Google. Google is the Haskell one, and Noogle is the. Let's search for pipe. Oh, so it has to be. Oh. Like I think. So this is the one we want, right? I take in an A and then pass it to pin and give them. This might be the one, the type. Okay, they have multiple pipe operators depending on the content. In that case, we can do we can do something like this. I think dot, I think that's how we compose functions. At least that's what I saw in here. If we switch for dot, yeah, this is how they compose functions. But the order has to be, let's run this and see the error at least. Okay, I think the order maybe may need to be reversed, right? So dot on, couldn't match expected int with actual type string int. Oh, okay, yeah, of course this has to be, we don't need to take the string out. Yeah, so they want us to use this dot operator to compose instead of using the pipe operator. But where is this? Maps over core expression. Yeah, let's look for examples of do they use pipes here in any way? They don't use pipes. They don't use pipes. Okay, so we can parse an input line with this. So this will give us an input line. So what we need to do is we gotta have a parse. I guess let's call this parse number line. Parse number line, and then we need a version of this called parse operator line, operation line, operation line. So this will instead return a list of operation, right? Operation, and then we can create a function called toOperation. It's gonna take a string, and then it's gonna take a maybe, it's gonna return a maybe operation. And then this is the stuff I love about Haskell. You can just pattern match with the function definition. So we can do, if it's multiply, then it's just a what do you call it? Just a mul, and multiplication. If it's a plus, it's just a add. And let's run this. I think maybe at this point we might need to do maybe two operation. Oh, it worked. Does it automatically infer the base case? I don't have to tail it? Is that what you're saying to me? I don't have to say when it's everything else do nothing? It just infers that? I don't think so. I think it does. I don't think it should. But I think maybe it did. So we have our parse operations, and we have our we have our number line. So the parse input is gonna compose these two functions, and it's gonna return a string, right? A string, and then it will have two values in it. It will have a list of operations, a tuple. It will return a tuple, and then it will have a list of numbers, the grid we are talking about. Yeah, I think this is it. Okay, so we can say parse input. We might need to have some state for this to restructure out the last element. Yeah, I think this will need some kind of okay, so let's see. I think let me close this. Close that. We have all the how much? Okay, nearly to 400. So let's see. Where are we? Late. How do I define variables? Late in. or I can just say late and then do the expression. I can say late something like that, and do this, and then just do output. Don't I have to say late in or something? Parse error late in. Okay, it's late in. Yeah, let me just drink some water. What you're gonna need is the lines, and we saw that we can do that with string.lines, and then s, and then we're gonna need to take the last element, late last is equals to, I also saw something like that, I think last, yeah, so you can call list.last. And then list.last. Oh, this is gonna be operations, I guess. This will be of lines in. But this is gonna return, I think, maybe, right? So, extract the last name. Warning: this function is partial. Consider using an association state. Okay, it's maybe. Okay, so partial means it will throw an exception, or because all of the valid cases are not covered. For example, if this was covering all the valid cases, operations could be, the list could be an empty list, and operations could be nothing. So this should have been returning maybe, but to just help us, I think they made it be a partial function. Yeah, so we can still do this. Okay, so yeah, I think so they're helping us then, and then so we can say parse operation, and then we have to remove the last one from this, or we can just say, I guess, let's do this, operations, and then there must be a drop or drop. Okay, drop in returns the suffix x's after, or I guess take is what we want. Take the first, so let's call it, say count is gonna be things, list lines in, and then we can say take lines count -1. The numbers is gonna be this. In this lines list. Okay, so this will be a list of strings, right? And then we need to call this on all of them, so we can say list dot map parse number line on numbers. I think this is it. No type errors. Nice. No compile errors. Okay, so now we can parse our input. Yeah, I don't know. I guess let's do this. Let's copy paste because we can't. Installing the language server hasn't finished yet, so I'm gonna do something like this. I'm gonna say input, and then how do I define a multi-line string? Oh, it's not what I copied, is it? I copied this. Paste. Is this how you define a multi-line string in Haskell? Multi-line string Haskell. I guess it could just be the normal string. I think it might be already multi-line. If we do that, no, it's not multi-line. How do you do that? Oh, you have to do. Oh shit. Okay, that's annoying. Okay, there. Yeah, it's saying we have to do stuff like this at the end. It's still complaining, I guess. Multi-line string. No. Multi-line string. Let's go to Stack Overflow. Yeah. Okay. You can write multi-line. Okay, it has to also start at the next one. Okay. It also needs to be here. 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 Is that enough? And then also here. Or I guess this one doesn't need to be technically be there. Okay, that was annoying, but what I wanted to do is call late parse down and then equals parse input in, and then debug print Haskell debug.trace. Let's import that. Import, and then I guess I can just say how was that being used? Trace calling. Maybe we don't have the. Let's just print the numbers for now. Numbers, and then let's ignore the operations and let's say numbers, and then show numbers, and then I guess numbers. We can do something like this, in, and then do a tuple. Of course, this needs to be an in there. Oh, okay. Where is the trace output though? Okay, I'm gonna say str. str. Oh, numbers is an empty list. That's okay. That's surprising. Do that. Of course, there will be a type error, but at this point, it's a list of string. Maybe this show numbers thing doesn't work. Show one. Okay, show hello. Maybe we did something wrong with the take. Take. Take in applied to a list of access returns the prefix access of length n. Okay. Maybe something like this. Let's just see the lines then. Okay, these are the lines. Oh, we got, maybe it's because the new lines got removed. There should have been a new line here. It's because we're hard coding the input. Yeah, it's not being split correctly, I think. And then this. And then we have the list or map and part number 9. And now it's back to returning an int. And then we need to give it the numbers. Okay, 1 2 3 3 2 8 51 64 45. And then what we need to do is a kind of map in kind of situation, right? A map in, and then we'll take all of the first element, a list of the first elements. I think Haskell may have that. Haskell list map in. Returners. This is not what we want to talk about. Mapping on nested list. While map works on a single label of a list, the concept of mapping often refers to applying a function of elements within a nested list of Haskell's type system prevents a single mapping function from existing that can arbitrarily handle any types of nesting, as the type would depend on the runtime value of n. Okay. I guess there is another one. I guess what was it? There is a way we can take in a list of lists. So let's go back to and see where we have double. Yeah, interlocate. What is this? Intercalate. I don't know how to pronounce that.
Intercalate.
Intercalate. Okay. Intercalate x access is equivalent to concat intersperse. It inserts the list access in between the lists in access and concatenates the result. Okay, that's not what we want. Of course, that's not what we want. That is not transpose. The transpose function transposes the rows and columns. That's exactly what we want, right? So transpose, so what we want is we want 1, 2, 3, 45, and 16 to be in a single list. Beautiful, beautiful, Haskell, beautiful. Okay, so let's do transpose, and it's a single function called transpose. It's doing, I think, a matrix operation. That's called, I guess, yeah, transposing is a matrix operation. Nice, we got it. And then basically we can do a map too, I guess, to mash them along with their operation, and then do create this list of columns, right? Um, so nice. Okay, map to, or uh, map over two elements, map over two arrays. So what we need to see, the type. Another good thing about Google is it actually lets you search for a function with their type. So what I'm gonna say is I want a function that's gonna take an A and turn it to a B. This will be the first function parameter, or no, let's say it's gonna take an A, because it's gonna take two parameters basically. It's gonna take an AB and then return a CD, and then it's gonna accept an A list and a B list, and then it's gonna return, oh, I guess it's gonna return, so C, and then it's gonna return a list of C. This is the function type I want. Or maybe A comma B here. Right, this is the function type of a map to map over two arrays. I didn't find it. Okay, maybe I did something wrong with my type definition. Let's say Haskell function addad. Okay, it's called a zip with. Oh, come on. I know why Google was. It's carried, not passed in. Okay, we found it, right? So you can search for a type. You can search for a function without even knowing its name. Something like this. I think we talked about this on the first day with Unison. Unison also supports this feature. Actually, the Rust docs arrays also supports this feature. Yeah, it's really cool, especially for discovering, like for finding. So I guess the function is not called map2, but it's called zipwiz. But yeah, Google already told us that. Yeah, so basically you can give it two lists, and then you can give it a function that will zip it together, and that's what it is. So what we're going to do is first of all, okay, let's create a two columns, right? And then it's gonna take an operation followed by two-dimensional list of integers. It's gonna return a column list. And then how is it gonna do that? It's gonna take two columns, and then it's gonna do gonna do a transpose, I think transpose, and then the function application, I think $sign is the correct one when we want to be left to right associated. Like we want the precedence to go from left to right, so we're gonna transpose it. We're gonna transpose we need to destructure out, actually. We need to destructure out operations, and then numbers. And then let's do this. Let numbers is equals to, right? And then do transpose, I guess transpose numbers in, and then we can say list.zip with, and then we can just give it the constructor column, and then it's gonna be over operations followed by numbers. Let's print that out. I'll just run that. Oh, I forgot to close that here. And then this can be transpose numbers. Okay, so we can call still name this input, and then columns, two columns, then input, and then let's try to print the columns. I think it's gonna complain that, oh, you don't have a where implemented. Okay, what is expected? String, actual, where, on parse input. Okay, we can say, we can call this parsed, and we can give it the parsed. And then, yeah, so I couldn't match any type column with car. Expected string found a list of, yeah, a list of column. Okay, I think what we need to do is say show, and then let's actually implement show for our list. Yeah, and then Haskell implement show. I think I saw something about that here, where you do class, I think class, and then instance. Yeah, maybe we need to do something like that for show, or deriving show. You can just say deriving, it can be derived. Okay, where are deriving, and then deriving. Nice. Okay, so let's go back here and say 1 2 3 45 multiply. So it's exactly telling us what to do. Multiply 1 2 3 45, add 328 64 98, add that. Hopefully, oh, these are finished. Okay, nice. Let's see if Helix now recognizes it. Yep, let's make directory 5. No, oh, we're on by 6. Let me increase the font. Then I guess let's do an X format, and I think now we can do Cabal. No, we didn't have Cabal. Thought you had Cabal. Okay. I guess we don't, but we do have JSC. Okay. So I'm gonna create a directory, make there part 1, and then going to part 1, make their inputs. I checks inputs example dot text, and go back here, paste that in, and then let's create part1 dot hs Haskell or Haskell file. Let's go back here, let's copy this, paste that all of it, put all of that in there, and then how do you format a Haskell format? No, I mean format file. Haskell source code formatter. What do they use to format their source code? What is it? Just called Haskell formatter? Haskell formatter. No, we don't have it. But let's try doing this. Let's see if it actually compiles. So I think to compile, you just call GHC. So I think you just call GHC and then part1 dot Haskell. GHC. This is one of the coolest names for a compiler that I've ever there is no other there is no other compiler out there that has a better name. So GHC is the Haskell compiler, and it stands for the Glasgow Haskell compiler. I don't even know why they named it that. I don't even know where Glasgow comes from. And then okay, the Grace Hopper celebration. Okay, that's also a cool name. Grace Hopper is, I think she invented the idea of compilers. I think she invented the compiler, COBOL basically, if I remember correctly. COBOL. Yeah, known for COBOL. Yes, people didn't think about the idea of a compiler that would just take your one form of source code and then transform it, or the idea of a higher level language that can be translated into a lower level like instructions. She's the first person that came up with this. So I guess GHC could also stand for Grace Hopper Celebration or Gulfers Council. These are other fields, but Glasgow Haskell compiler just sounds cool. Okay, I think it did compile it. So we have this part1 binary here. Let's see how big the binary is. It's 30 megabytes already. Wow, that's why it took us almost. Okay, so it works. So we actually know that it works. And let's take a look at our language server. I don't think our language server is working correctly. Let's do a log open. Okay, if you are seeing this in a terminal, you probably should have run without --lsp option, logging heap, plugin IDs, a starting server. Okay, let's close this, and I guess let's write this, and then let's open it up again. Oh, now it's working, I think. Okay, now the language server is working. I think maybe it didn't work because it didn't see any files. It didn't see any of our why is it complaint? Let's go over the actual complaints. ETA found to int, why not? Oh wow, whoa! Is it basically? Do you guys see this? It says found to int s read maybe s. Why aren't you just doing to int is equal to read maybe? Cause reduce this, and then if I say apply action and then ignore hint, I'm gonna say apply hint. Please check your setup. Please check your setup. Oh, okay, that's actually broken, but I think it's the compiler is giving me Clippy insights. Like in Rust we have Clippy, and it gives you insights like this. Wow. Okay, and then can we see the type of different stuff? I don't know. I think maybe the language server crashed on us. And then let's go over here. What other hints does it have for us? It says redundant bracket found. You don't need this bracket. Thank you. And then it's also saying you don't need this bracket. Thank you very much. And then we can go down here, saying the same thing. It's also saying that down here. Why not use print? Okay, print, and then columns, and then JHC. Still the same. And I think we need to add a git ignore here. Let's look at all the files actually. Part 1, part 2. Yeah, so it's creating a bunch of junk. Let's say everything that it chases, everything that O, and the actual binary itself, part 1, and yeah. Okay, but I don't know, the language server just keeps on crashing. I don't know why. I think it did crash this time. Okay. So now we're actually parsing, and we just need to create an apply function. So I guess we can just say we can say somewhere around here compute, and then it's gonna take a column, and then it's gonna return an int basically. So, and then we're gonna do compute equals fold left, right? And then we can say compute for operation I guess we can say apply op, and then we can say it takes an operation and returns something that will take an int and an int and then return an int. Apply operation for multiply is gonna be something like a b, and then do a times b for add be the same, but here will be, so we can say here fold apply operation. We can basically just call down op nums, then we can say op then nums, and then we can say solution. Let's remove this, we don't need that. Solution equals map, or let's say solution will be a list of columns reduced to a single int. We do that by calling I guess map list dot map and then compute on the calls, and then I think we can do something like this. We can say because there should be let's go into Google, or what was the name? Did we close Google somewhere? Google, and there should be something that takes a list of ints and then returns an int. Size, sum. Where does this come from? There are a bunch of different sum methods. Sum, mono, that's what we want. Monomorphic sum. Okay, that's what a normal. If that's what a normal sum is called, then that's what I want. Give me that. And it's part of parf_algos. Import parf_algos. Let's try to compile this. It's saying could not find module parf_algos. I think we don't care actually. We don't care. We can easily define a sum function here. We can say sum. It's gonna take an int list, return an int, and then it's gonna take sum. This is gonna be fold left and then plus. Or I can just do fold left plus. No, where's plus? Here. And then, GHC. Okay, the type signature for solution lacks the combining by. Okay, this should be solution. Okay, it's saying variable not in scope input, variable not in scope apply operation. Oh, it's gonna be apply op. This is apply op, then JC. Okay, could not match could not match expected type int. Oh, okay, of course. When you do a fold, you need to give it the starting condition. JC. Or I guess that needs to be this way. Or actually our default, our base accumulator depends on what kind of operation we're going to perform, right? So if it's going to be so we're gonna return a base acc, and let's do apply op base acc, and it's gonna just return a single int, and then this will be, for multiplication it will be 1, and then for addition it will be 0, and then we can say base accumulator op GHC. Yeah, and then same thing here, GHC, and then it's complaining about input not existing, but read file to string Haskell. Okay, we want let's call this input, and then it's gonna be in inputs/example.text. Yeah, let's see what this does. Oh, I guess we need to do a do column there. GHC. So we can say, I guess instead of doing that, can we do this for rows as well? I think we can do that. I don't think that's possible actually, but let's try GHC. Yeah, it's not possible. So what we need to do is combine this into a single, combine all of them together. It's gonna be parse input applied left associative. I guess we can say input, then parse input, and then 2 columns, and then print. What's the last call? I think this should work. Like this, or we can say print dot parse input dot 2 colon, no, parse input of input, maybe, and then I guess we need to this also we need to do something like this before we print it here. Let's do solution, and then part 1. Is that correct? That does not seem correct. Oh, I think it is. And expected to be a large number. Okay, let's do this for our actual puzzle input. And then save this to input.text workspace. Move input to inputs. And then here let's do input text GHC compile part 1. Oof, and that's until now you're too low man island bitcha. Oh, okay. You got 1 gold star. Yeah. Okay. I think before we do this, let's go to this, the leaderboard. I think it's been an hour, so I think some people might have even finished. No, I guess David Mangusto and me are doing it, and we are both. So I think David has also finished the part 1, and yeah, I think David has also finished part 1 for day 6. But let's go into day part 2. Okay, but I want to do something before that. Let's do. Okay, it's not giving us any warnings. Okay, let's see what it's saying. Let's look at the diagnostics. Okay, it's saying avoid lambda found. Why not? You're right. You're right, compiler. You are absolutely right. This should be just this. This should be just that. Oh, it's saying, but it's saying, oh, okay. I know, okay. Do exactly what the compiler says. So you're absolutely right, compiler. Why not use sum? Okay, there is a sum. What did I type? Okay, there is a sum. And then let's do GHC. Nice. This is. I like this. I like this a lot. Now let's do this. Okay. Commit feed. Commit implement day 6 parts 1. close this, go back, go back, and then CPP, the comments part of channel. Let's do the PPR and part 1, part 2, and then let's rename, let's kill all of the, I guess let's rename part 1.hs to part 2.hs, and then let's rename all the part 1 gibberish stuff here, part 1 hi, and then the part 1 binary, let's move that here. We can just go into part 2, and then let's go into part redundant brackets. Let's go into part 2 and GHC part 2, and then I guess let's apply the edit. It just adjusted to this as well. That's autumn. What? Oh, it was like this already? Okay, and then I guess what we need to do is get in here, update this to b2 so that we don't actually accidentally commit it. I think maybe we accidentally just committed hi for the previous one right here. Oh no. Oh no, okay. That's gonna be a nasty bug to debug. Let's do this, I guess. Let's reset the hard and then head tilde 1. What about the this stuff? What? Did we just lose the changes we added to the flake? Let's pull it again. And then this change includes the flake.nix. Let me do, and if I do git reset hard, yeah. Oh no, one, I guess. No. Git checkout main. Git reset hard. Oh, I guess I don't want. Okay, I know what's happening now. Let me just pull again, and we want. We don't want. Yeah, it's not gonna be. Just have to do head tilde 1. Okay, now we still have the changes to the flake.nix, but let's go in here, and we were git ignoring the actual source code, and we were Yeah, so it's going to die 6 part 1, and it's going to argit ignore, right? And here it should not be a chase, it should be a try, right? And then we can just add a try. Then if we go into part 1 or a chase, no, part 1 or a chase, see something, yep, save it. And then now we can git add this, and then so git add flag dot log, flag dot log, and I get flag dot mix. Now this is what we wanted to do. Okay, commit, yep, and then push force. Okay, now let's actually read this. The big safe leopards come back to check how things are going. When they see that your grand total doesn't match the one expected by the worksheet, they realize they forgot to explain how to read safe leopard maths. Safe leopard maths is written right to left in the columns. Each number is given its own column with the most significant digit at the top and the least significant digit at the bottom. Problems are still separated with a column consisting only of spaces, and the symbol at the top, at the bottom of the problem is still the operator to use. So we need to invert the numbers, you're telling me? It's written right to left. Each number is given its own column. Okay. The rightmost problem is 4 plus 4, 3, 1. What? And then 6, 2, 3. Where are those numbers coming from? So it's 6, 2, 3, 4, 3, 1 plus 4. Okay. Okay. And then the second problem from the right is 175 581 32, and the third is 8 plus 248 369 356 241. I think we need to completely we need to redo the parsing logic. Yeah, I think that's what we have to do. I guess the operator parsing could stay the same, but we need to redo the parsing, the parsing logic. Yeah, it's gonna be simple. We just gotta do separated by a single, no, separated by a single space, and then we can see the groups of. Now we could have the group of strings. That will be a list of strings, and then we can go over the list of we can even separate it out to a list of characters as like a 3-level nested list of characters, and then we would do transpose on. I don't think we can use transpose, but we can, if we are able to have this be in a grid, have these values be in a grid, we can transpose them. But yeah, I guess today is a parsing problem. So let's go back here and say this parse number line is not gonna work, but we still need it. It's still useful for us, but here it's now gonna return a string, a list of strings instead. So we're gonna just parse these groups of numbers. or this including the front padding. um, I guess we can't really do that, I guess. So I think what we should do is let's keep it this way, but let's say it's a string, um, and then we can say, instead of that we can say it's even like something like this, car, or like even, let's go even, it's like something like this, right? Something like this. We need to separate this out into separate digits. um, so this will be, so the current row and then the next row and then the third row, and then we need to go from left to right, from right to left. We need to remember that because it's 3 5 6 2 4 and 1. 3 5 6 2 4 and 1. This is actually not safe lapad mods. This is how you do like normal human mods when you're elementary school manam, I guess. Yeah. So let's do this. So it is gonna split them into words. It is gonna convert them into int, but even after doing that, it's gonna list. Let's do this. Right, and it's gonna convert all of them to an int, and then we're gonna have a split number kind of situation, right? It will need to do 3 2 1 or yep, it's gonna do 10. It's gonna do that, and then yeah. So okay, so let's go back to Google, and Google, I think maybe there are some things we can close. We can close this div page. Let's not close that. Let's not close that. No, we can close that. We can close this. Let's have it open. Close that. Close that. Close that. This is not needed. Not needed. Nope. 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 Okay. So what I was gonna do is, let's create a, we can convert it into a string and then do a split and then convert them into a number, but let's say digits, because it will help us. I think this is a chance where we can do some kind of recursion in this thing, digits. So we're gonna, for example, when we're given when we are given, let's say we get 1 2 3, we need to separate this out into the integers 1 2 and 3, and how you do that is gonna be something like this. So digits x is equals to x divided by their modulo by, right? So I think that's how we do it. Mod x 10, something like this, and then so the base case is going to be finally we're gonna always end up at 1. So if we are at 1, you're gonna have an empty string. Otherwise you're gonna do this, x or we can say since we will be reusing the mode 2 times, we can do something like late power equals in, and then x divided by the 10 the power of. Is that how we can do it? No, I don't think this is how you do it. Calculator. Let's do log 300. Yeah, that's not how we do it. You can just do 321 by. Oh, I guess you have to keep on just dividing by 100, dividing by not dividing by not 100, but dividing by 10. Dividing by 10. Until you get 1. Yeah, so you don't do this modulo bullshit. So this can be x divided by 10, and then it's gonna be right. When you do divide by 9, you get 32, because we're gonna, and then you do 32 by 10. Oh, you would be adding 32 into that list? No, that's not what we want. Let's do, I guess let's do, I was gonna search for this in Google. I think if somebody has already implemented it. Google. What's up, Crunch? What's up? Yeah, and then you do digits dot x minus x to the power of, no, not divide by 10, I guess. I think this is it, but I'm not sure. Let's do this to debug, to make sure this works. Let's comment this out and say, let's have our own main function here. Main main, and then we can call digits on 1, 2, 3, and then print that GHC. Oh, I guess okay. Let's do digits, map digits. Not in scope, type constructor and minus. How do you subtract numbers then? Not in scope, constructor or class. What? What you talking about, Willis? I can't do an x minus 1 situation? Is that what you're telling me? I guess it's complaining about other stuff now. Uh, then I guess it's complaining about parse number line no longer existing, or returning a different type now. Yeah, okay. So this will be just, I don't know, ignore that since we're not gonna be using it now. Is digits returning the wrong type? No, it's not. So if I remove this, it was just if it was a list of numbers. Okay, see? Oh, I guess it's another error we didn't catch earlier. Possibility to do. Okay. Couldn't match expected value string to int with actual value list of strings. No, I guess we need to do this then. Okay, we know that words returns a. We know that words. This returns a. Just gonna accept a string and then return a list of strings. And then map maybe expects a list of strings currently, but it's saying expected type string. I guess there is an issue with how I'm using this. We can return back to the old way of like doing this dot. That could work. Then here we can say map digits, and then see that, and then we can update the type to be GHC. Okay, so let's try doing that. It's gonna return 1 to 2. Okay, I guess recursive the int 2 digits base 10 argo rhythm. Oh, you can. Okay. So what you need to do is you're gonna do x divided by 10, and you're gonna add the modulo while n is greater than 0. I guess 1, and I guess if we get called with 0 2, we just return an interest. But this is what we call digits x modulo 10 x modulo 10 and then you can say yeah, this is, I think this is how we do it. But it's saying, what the heck is this? I don't know. Is it saying we can't divide an integer? Okay, let me just this is the actual error. Illegal type 10. What does that even mean? Let's say GHCI. I want to create a function called a, and then a divided by 10, it will return a 10. A 100. Could not deduce fractional. What? I guess there is a special way to divide numbers in Haskell. Int divide divint. We have to use this divint stuff. Come on, what the fuck is wrong? What the heck? Used to implement div for, so we need to do you're telling me we need to do div here, stuff like something like that. GHCI, no, GHC part. But it's saying it's still an illegal type, so maybe we have to specifically say it's a div int GHC. How is 10 an illegal type? It's not a type, it's a number. Maybe do we have to tail it? 10 is an int, and then 10 is 10. Is this what you want me to do, Haskell? GHC. Okay, now it's saying I don't like that you're using a modulo, so there must be a mode int then. Wow. Okay, mode int, and then now it's saying it doesn't even like that we're using a mode int. What the heck is this? Okay, couldn't match type div int with int. What does div int return? It says here it returns an int, but it's somewhere around here. It's getting confused. Variable not in scope, mode int. It's from the base. Import data base. I thought this was the prelude. I guess it's ghc.base. Do you want me to import ghc.base? Couldn't match expected type digits with an actual int in the expression x mod int in an equation of what? How is that? Oh, this is crazy stuff. Okay, let's look at the errors we're getting from the LSP now. Parenthesize this. Haskell dividing integers. Why is it impossible to divide an integer in? Is it really impossible? No instance for what the heck? Because integer has no fractal instance. The type, okay. So if you want to perform use div, which is what we were trying to do. Where is this from? The heck? Let's say, and then I guess we can say mod and div JC. Still doesn't like this, but now it's complaining about a different issue. In the first argument of mode, namely x, the expression x mod 10 digits in the equation. Okay. Cannot okay, cannot couldn't match expected type. I do not know what's happening. I think I'm just gonna why doesn't this Haskell compile? Wait, did this actually work and they got them? So if I say 10, whoa! It was having trouble inferring that 10 is 10. 10 is an int, that's what I'm trying to say. What? Yeah. No, it's still complaining. But now it's saying, no, okay, this doesn't compile either, but okay. We mislaid the GPT with that data, but let's do this. Let's do that. Let's do this, and then let's give it the error. Oh, the list constructor is okay. The errors were misleading us, but I'm back about it, I guess. But yeah, this was the errors were misleading us. It was we weren't using it's supposed to be a single column. So 3 2. We gave it 1 2. Okay, so and then in this case, when we get to 1, we should include 1. I mean, we need to compile it first, and then this should work for a bigger number like 5 9 8 7 6 4 4 5 1. But it is reversed. I can see that, but we can reverse that. Okay. Here it was mentioning something about how we should reverse it. I don't, we don't care about numbers that are less than. Oh yeah, where? Okay, so we can say digits. We can do this take this out, and then digits, and select, and at the end of them add this, and then in here we can say digits equals digits where, and then we can do where's Google rev or reverse GHC even if it does it complains. Oh, okay. Ah. Okay, yep, 5.9. Okay, so now we have a list of lists, a list of lists of lists of a list of things. Now what we need to do, and then go over each one, and then it's like a zip whiz, but with I guess it's gonna be, we should do the transpose. We should do it's gonna be a transpose, and then we're gonna actually what, now that I'm thinking of it, we shouldn't actually reverse it, right? Because they said we're gonna need to go from left to right to left. So, and then we can say, so let's just comment out this, comment this back, and comment this back in. Now this is gonna be transpose it. So we have a lists of integers, and then that's also part of a bigger list. So what we have here now, currently what we have is, let me just copy this, and yeah, I think what I'm thinking makes sense. So we have that, and then if we transpose it, it's gonna be, we're gonna get a list of 1 2 3 4 5 6, and then 3 2 6. Oh yeah. Yep. How much time how long have we been training? 1 hour and 54 minutes. Yeah, we can just do what I know what we're gonna do here. Let's actually see the errors we have. Of course, this shouldn't be there. It shouldn't be there, and how is that not complaining? It's just I expected that. Yeah, that's complaining. So this is gonna end up being something like that. Then JHC, and then let's forget about 2 columns for a second, and then JHC, and then we don't care about solutions or also. We just want to look at what the input looks like now. GHC. No, example. GHC part 2. So we have melt method, that's expected, but we have 321 823 321 823, yep, 1 5 321 823 1 5, and then 4 6, then that group closes. So now what if we do this, transpose that final thing, right? So JC. Okay, now we see 3 2 1 5 4 and 6. This is exactly what we want. Exactly what we want. Exactly what we want. So yeah, now we just have to zip over this, right? We used zip or zip with here. So what we need to do is so it's gonna be 3 5 6 2 1. So we need some way, like a map in the function. Yeah, let me just do that. So we're gonna create a function called, so this is our new input. So, and then we need to be able to, after parsing the numbers and transposing them, we can actually move this into a parse numbers kind of thing, right? And then this is supposed to, it's gonna take a list of int and then, no, I guess it's gonna take a string and then it's gonna return a list of int. Parse numbers. No, it's gonna take a list of lines. It's gonna take that. No. Move this up here. Equals. Paste that in. And then here let's call parse numbers instead. From the numbers. Actually, we just need the. What if we try this? Then let's do. Let's forget about that. Will this work? We created with that. Maybe we need to take out the numbers. In numbers. Yes. Don't work. Too many arguments. Okay, so and then I guess we just put this in a variable, right? Numbers. And then what we need to do is, I think from the earlier logs, so we need to iterate over them, taking the first one from each list. So let's go into Haskell function for iterating over nested lists. Map inner, map, double map. Concat map. Concat map flatten. Okay, that's something we I think that's it, maybe. But what is it getting? So it's getting 2 times 1. But what we need, our use case is a little bit different, right? So let's return numbers here, but maybe I think we need to define our own custom function. But I think there's a chance. No, there is a chance that this will return the correct. Yeah, so we're gonna need to iterate over this list, and then so it's also contained within a larger list, right? Which contains let's actually let me just copy this and let's see the structure down here. We have that, and then that, okay, that, okay. Then we have a new line where we do the same thing, but it's 3 levels of nesting. So it's gonna be done. we need to map over the top level list. Okay, just copy map list map out, and then we can say so, and then that will be called over this list over here. No, not but this list, and then we need to have a combine numbers kind of thing, so it will accept a something like this, no, something like this, and then it will return a single this. And then that will be called non-this combine numbers. How how are we gonna create this function? So the input is gonna be this, so in and out, it's gonna be 3,5. I guess it's still gonna be, because we haven't implemented the combine function yet, this is gonna be 3,5, no, 3,5,6, and this is gonna be 2,4, and then this is gonna be 5. Yeah, 3, 5, 6, 2,4. Oh, 5 is already used, so this should be just 1. So this is gonna do, it's gonna take out the first value, it's gonna take out the first list. If that itself is a list, and then there is a list next to it, it's gonna keep combining it, or there is a list dot map we can do here. And what was the example it gave us? So it's a concat map. Let's look at how concat map works. That's not really what we want, right? That's not what we want. Take 3, 5, 6, like the first element, keep on adding the first element. Once that's exhausted, how do we know that's exhausted? When we reach the end of the list, 2, 4. We want to map over the list, but we want to get all at position, or it's like all at Yeah, all add position, all add position, all add position. Fuck. I think we need to creating this ourselves. So this is gonna be something like combine numbers, right? If it's an empty list, maybe we should return an empty list. I'm not sure. Combine numbers. If we have a head and the tail, and the head itself is a this took only two different kinds of map in or what kind of type am I expecting? I want a type that will give me a function with call me with a b, and then I call it with a list of, right? This is the type. Oh, it also should return a list of b. I guess, is there a mapping function with this type in Haskell? That's not it, but okay. Okay, so for a non so there is like some maybe we need to, where are we going? So I think, what if we did none and stuff here, but I think that's not gonna be a problem, because if it just can't find them, it should we know that max length of a is equal to length of I guess but the a that is passed to the mapping function is all the elements from all the element from the current index position in the yeah. No, not that. Tails 1, 2, 3. So your desired function is use init to remove the final. I guess let's give it an example with this. Oh, what an idiot! It is a transpose again. Oh no! It is a transpose. You just gotta do a transpose again on the transpose. It's a double transpose. Oh shit! Oh shit! Where was I calling combine? It's gotta be transpose. That was a mind-blowing thing. Okay, so I think it's actually. How did I not notice that? What is it saying? Illegal term define JC. Where? On line 53. 53. Three five six two four one. Oh my! What an idiot! How did I not know till now? It was a transpose. And then the final function we need is we actually implemented this on, I think, on day 4 with Idris. Where is it? I think in here. We implemented it with Idris. Let's go in here. It was in day 4, I think. Yeah, day 4 was Idris. And it's going to, there is a, I think it was day 3. Day 3 is when we used Idris. Yeah. Yeah. Okay, so what we need to do is there is a combine digits. Yep, this is the combine digits function, and then we need to copy over that. Shit! It was a fucking transpose all along. Transpose all your matrices, matrici, or is it matrices? So combine digits is gonna take list of ints, boom, it'll give you back an int, but what it needs to do is first it needs to reverse the x's, and then it's gonna call list.map I. Haskell map I. Map no, oh no, actually I never tried this. Haskell map with index. So there is no map with index, I guess. It's this, but we had our own. I'm not gonna use that. We're gonna port some Idris code to Haskell. We had our map with index here. Let's say where map is index as this, and then next dot in bind digit 6. It was a transpose, god damn it. Okay, map with index B, something like that. There are gonna be a bunch of errors, some Haskell's we need to convert to some is type definition int to A and to B. Okay, and then it needs to be I plus 1. See. Where did we define 10 earlier? We defined 10 somewhere, 10. Or I guess we need to do something like this now. We need to do something like plus. Is that what you're telling me? Let's see. Go is called with an int, which is an I plus 1. Shouldn't this be like this? You tell me we need to put a tick in front of it? Why though? What is it saying? It needs to be I plus 1 and then JC. Perhaps you intended to use data kinds. One illegal type 1. There is something earlier here that is not happy with. Yeah, I know what it is. It was the same issue as the previous one. It was the consing operation. Yeah. And then now we have new errors. And of course power, we also need to port that. Power. I guess here it's gonna be power. I think didn't we implement power ourselves? No. Power. No, it's built in. So here its state will be pow, hopefully. GHC does. And then of course this need to be a composition and see fix. We know what. Okay, let's go and start it. Maybe it's something like this. Get I int followed by the current value, and it will return some p. The relevant bindings include JC. It's saying it doesn't know about the type. Okay, so these are the types. This is this. It's that. Or maybe this destructuring operation is not correct. GHC. Okay. Couldn't match expected type A with actual type A1. A is a rigid type blah 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 blah. In the second argument, I guess how do you cons list? Okay, this is how you spell it out. Okay, it's just a single. And then to combine it, you also just do a single. Maybe parenthesize both sides. I'm not sure. Okay, let's fix that first. Integer power Haskell. It's just okay. There. Power. I guess we need to do a dot operation instead. So it should be some dot this and then dot what is wrong with this? nothing is wrong with that definition, or you're wrong. I thought there would be nothing wrong, but apparently something is. The type inference, we've specified all of our types, but actually let's forget about this. Actually forget about that. We don't need to care about. Let's remove all references to, I guess, we know that we're gonna just pass in int to it, so why keep our types? This function doesn't need to be generic. We know exactly what we want from this function. Int, right? Okay, now it compiled. Yeah, the types were too broad, and then I think we needed to add some type bounds to have it compile correctly. Okay, and then so after we transpose, we need to map over them, and then do combine. I guess we need to do a double map over the map, and then combine digits. And then this will give us a list of yeah. So we removed one level of nesting. Beautiful. And then now we can call, let's go into part 1.hs. Let's go and do that. Boom. Right, it's called ghc compile, then part 2. Okay, oh, that seems way too large, but let's check it out. That's not the number. This should be okay. We can verify this easily. So what is this? So this is ثلاثمية وخمسة وستين طيارات. 365 365 طيارات and 365 طيارات and 8 ولا 93 ثوست 8 4 no that's wrong 8 4 8 4 ثوست list. Whoa, what? That's incorrect though. That's incorrect. So let's add a debug. Did we get tricked? I thought it would work. Oh, transpose won't work because I know why transpose didn't work. You can see like here, we need to add in null values here to have the transpose work correctly, right? So if we just transpose this, it will be 848. So we need to come up with our own. So we need to update this. Instead of doing string words, we're gonna have to do a split, or a string dot split, and we need to pad the numbers. Where are we converting them into a list? So when we convert them to an int, no, when we convert them to digits, we should know what the maximum, we should prepend them. If they didn't, if they don't have that length, we need to prepend the, yeah. So I think, so this should be like 0, 0, but when we turn it into, it will be 10 to the power of 1 times 0, it should be just 0, 0, 0, and then they will cancel out. So and then we need to know the width though. We need to know the width. I think we can, let's go into our input, actual final input, and here the maximum width I'm saying is 4. So let's just have the width before. So we need to do something like let digits first 2 digits in, and then here we need to prepend or concatenate. So list append, okay, yeah. So if length list, the length of out is less than 4, then out plus plus in something like this, start repeat 0 with how many times should it be repeated, out minus, no, 4 minus out, otherwise then just out. Let's see if this compiles. Don't they have a repeat? Blah 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 blah. Repeat. No, it's not part of the list, but it's just a repeat. So it takes okay, then I guess we can repeat and then take repeat 0, and then I want you to take, I guess that's where I want. Repeat 0 infinitely and then take the first 4 minus out. This is a weird repeat in int int repeat take an x, and then I want you to repeat x, but take didn't. What the fuck, dude? Don't they have a? I guess I'm just gonna do this and then just gonna make me repeating. It's gonna repeat 0 in and then take x from repeating. And then here we're gonna just do repeat in. Then they must have something like plus plus to concatenate two lists. Yeah, append this two lists. But why is it complaining? It's complaining because minus we know out is wait, what are they doing? So out, or let's say I don't know, not x, y, this is digits colon y, this is length of y, then x, then y plus otherwise y. Padding, and then this will be list. If padding is greater than the needed padding is greater than 0, then apply that padding, but only apply it at the end. Or maybe I think that should be applied at the front, right? Because when we do a transpose, oh no, I think that because we're gonna no, should be at the end plus y. So if we have a padding, that's a padding plus the list, and then this will be x. What the heck was that? And then this will be the list, and then this will be the padding. No, it didn't actually make a difference. So, what we need to do is let's try prepending the zeros. No, that's even more. And then, but let's see the numbers. Let's add a debug.trace to somewhere. Say debug.trace, or let's split it down to multiple steps. Let's split this into multiple steps that are being performed. So first this gets called, so 8x that, and then y, we at this point we have parsed the numbers, like y equals in. Now we have a list, so I think we should do a debug here. Okay, still compiles, and let's do a, let's print them out before, let's print them out debug dot, I guess, trace, and then we can say transposed ++ show that trace. Oh, it got stuck in a loop. You understand me? Debug.trace. It just returns a loop. Come on. guess in this case we have to go back and return Z. Okay, so GHC, no, not GHC, but 356, 240, and 100, and I guess 000. How did that came about? I don't know, come about. So we need to say if parent. Okay, what? How do we end up with 4 zeros? Well, no, 3 zeros. Let's make this 3 for the example. Part 2. But if it's there's still a 0 listed there. Okay, so 356 240 100, and then the next one will be 800, I think 848. That is because we are appending them. We should be like this. GHC. So 300 250 146 146. No. Okay, I guess in those cases the transpose is already solving that. So before that, we need to look at the numbers we're getting before the transpose. So let's remove that transpose and just look at that. Okay, now this is 321. Okay, that's correct. 054, and the final one is 006, right? 823 046, and then 089. Oh, that's 046. That's correct. That's how we want to go. We want to go from right to left, so that's not actually reversed. But when we do after we do the transpose, all of those zeros get get removed. If we do that, and then, no, and then this 300, which is correct if we're going from right to left. I think we need to add the padding after transposing. Is that correct? So 300, and then 250, and then 346. But it's expecting, so these things are, it's aligning these things to the left. they should be aligned to the right. Should be aligned to the list plus plus. Tenya put 356, that's correct. 240, that's correct. 100, that's correct. And then 848. This is where it gets wrong, where it goes wrong. So it depends. So some numbers are left aligned, some numbers are right aligned. Some numbers are left aligned and some numbers are right aligned. So for this one, we end up padding those zeros at the front, and we pad a single zero at the front. So how do we know? I think instead of trying to pad them, we need to come up with a better way to parse them. So we need to go over character by character, and yeah, and then just right. I don't know, is there another way of detecting if it's at this point we're just getting 64, right? So we don't know when how it was aligned in the original. Yeah, I didn't notice that. It can be from the left or it can be on the right. So we're just gonna drop the numbers based on just the way we saw them in the list. Yeah, so I think it's just gonna have to be a split. Split by words. No, not by words, but let's see, by characters. Onwards. Onward joins. Onlines joins, I guess. Let's do cars. Split. Split out, not split out of lines. Haskell cars characters. Can we know this without splitting the characters, which are getting 6 from? It's gonna be fuck. Okay, let's solve that real quick. No, Haskell split string to cars. We're already at 3 hours, I think, huh? Right? We are already at 3 hours. No, they provide the spacing. Yeah, I thought it will always be like, but the example you're looking, I thought if I padded it with zeros, it would be enough. But for some of them, we might need to pad it from the right. And my parser is parsing this sequence of integers first, so that's the first problem. So I'm losing that information when I just parse them to a list of integers. Where is that? Okay, they have a string is already a list of characters. Okay, in that case what we need to split by is, for the example we need to split by 4, by 3, I guess chunk by 3. Or we can add a split by query and group those if we go to the final input though, input, the width is always 4, I think. Oh no, it's not, it depends. Wait, are they gonna force us to use a regex? I think they're gonna force us to use a regex because the width alternates from what I'm saying. Pascal split string by regex. Yeah, let's use a parser, I guess. Right. What will be the parsing rules? It will be a list of digits immediately followed by a space. List of digits immediately followed by a space, because I think that's why. So they added a bunch of dead spaces for us at the end. No, they did not. Maybe it's just what happened when I copied it in. Yeah, for this they added spaces. Inputs dot text. Yeah. So it's gonna be a number, a sequence of numbers followed by a space or a new line. That's what we're parsing. Parsing. Haskell parser combinators. How long have we been streaming? Let me see. 3 hours. How long? Parser combinators. It's gonna be an integer. Is there an int or not, or number, digit? Oh, isn't there a built-in parser combinator? No. Should be one. I don't want to build one myself. Not an external library. Haskell built-in. And then show me a usage example. Oh, there is a decimal. It's going to Google decimal. no lazy builder. No, nice one. Where are you good? I think where are you getting those? Take parsec. I don't have parsec. Parsec is an external library. We can't use an external library. I think I don't know. That's not a good approach. Text parsec. Reads a single time. Look at the next time while content satisfy. Character consumes a specific string choice. So we're gonna say part HS. Yeah, instead of string dot words, we're gonna do something like split digit, I guess number chunk and parse numbers. Yeah, string list of strings, and digit is one of we need to import. I guess we don't parsec. Ah shit, that trick does. That's good. There is no built-in, I guess. Okay, let's try importing parsec. Okay, let me parsec. Then maybe we can install it. Import. Okay, parsec is already there. Okay. They're gonna force me to rename this column, even though I do as parsec. Yeah, imported name either parsec. Okay. Haskell import. Import qualified. Okay, import qualified. Then now we can be free. Okay, so let's define a let's define our parser. Parsec. So we have a digit. Create a parsec parser first. And okay, so our parsec, so digits. Okay, and then this is one of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a digit. That's a parsec parser string. No, that's one of would be a character, I think. Google one of, and then parsec. It's gonna return a character, so it's just gonna be a car, and a space is. Do they have space? They have a new line, so I think they might have space too. Let me say space. Okay, and then parsec. It's gonna be annoying, the qualified stuff. Just gonna do that, and then a number is gonna be many of digit, and then how can I say followed by? You can say followed by I can say many many digit. Say by. no, not zip by, but followed by parsec chain zip of digit many skip many one spaces. This has to be many one. We need at least one. So many digits. And then say bye-bye. Or delimited by, I guess delimited or and wait, many tail. Okay. Yeah, so this is gonna be many tail. The first space we get. What's that? What does that do? It returns the content before is consumed, but its value is discarded. I don't know. I don't know if this is gonna work. I was thinking about this now. So what I'm trying to parse is something like this. So it's like number space and then number. But even if we do that, we won't know the actual width. I think that the best way to do this is gonna be probably, oh, I don't know. How can we just split by a single space? Just go over each character and, but for this one, like, there could be multiple ones. So, but that if that we can, so I think maybe we can use the operations as our guide, as the operation width as our guide. The gaps between these will tell us the information we need. No, they won't. No, they won't. They're the same for everyone. They always start at the same position. I think even if we create our own custom parser, that's not gonna solve it for us, because if we parse like numbers that are like followed by a, we need to also support numbers by, and I don't think that is like, we need to support both numbers that look like this, and then they can alternate, like, and then we can have this here, and then we can have it's not gonna work. It's not gonna work. Fuck. How I thought parsing this would be easy, but I think maybe the best thing to do is just leave a none. Instead of trying to pad digits, we try to leave a none value here. So what I'm gonna do is I'm gonna just parse number line parse number line, and I'm gonna call it with these, just a single line of data, not that. gonna try to see what that looks like. So 32182315446. That's what I called right parse number line. Are we already inverting them when we? I guess we are. How do I didn't know we are doing that actually. Okay, maybe let's have this return a string inside. Oh, that's because we are mapping them like that. Then this could be an int instead. And then let's look at that. JHC. That's 123, 328, 5164. But we need to. We wanna keep. What if we wanna keep? What if we wanna keep the numbers? No. In this inputs. It's not like well, yeah, it's always it's different. It's always different. So it's gonna be something like this. We're gonna need to parse out like an int or a nan kind of situation. You don't know. I'm just gonna say how should given a string like this, how can we parse it to numbers without losing the padding info? Yeah, it's using the parser split preserving. Parse one of what? If it's an element of a number, say we got the token. If it's anything else, say nothing. And then we can have a string like that. So what are these parse out to be? Parse tokens. We need a split preserving is space. Net spaces dot race span is space races preserving. What does split preserving return? Our input doesn't have the zeros. What the heck you talking about? Okay, what if it's passed like this without the zero padding? And notice that for 64 the padding space is at the end. Okay, this is wrong. So we want to return something like this. So this in this and out that and oof. Instead of doing the spaces, we're gonna need to create our own integer, right? It's gonna be an integer or nothing, because if we just do 0, for example, when we're summing up the digits, when we're combining the digits here, it could introduce problems, because I think we're adding them though, so I don't think it should produce any problem. So I wanted to, so okay, instead let's return this. One, two, three, 2, 8, 0, 5, 1, and then 6, 4, 0. Right? If we just return this, I think in our existing implementation, we are going to map over them and combine them. So this will be, for example, 004. No. So, and then when 004 is being combined, it's gonna say, but it will cause problems for, like, I think for this one, this will be 8 times 10 to the power of 2, because it will be at the first position. Yeah, I think so. In that case, this will cause problems. So we need to come up with our own custom type. Let's call it no. So instead of returning this, it should be something like uh, 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 1 2 1 comma 2 comma 3 3 comma 2 comma 8, and then a type called, we're gonna say nothing, or nothing is too long, but I don't care. So 5 comma 1, then nothing, 6 comma 4, data number is gonna be int data just the numbers will be just the others. But if there is a space in the position of where a number was supposed to be, it will be nothing. No, in Haskell. Yeah, I think this is correct. I think this is correct. This is what we want. It's basically just going over each list. It's, I don't know if it's using the let's determine how it works. Parse groups, JC. Oh no. The first space after a number is a splitter, so that should just be dropped. That shouldn't add a nothing into the list. You need to check for the last value in here, not just check for the current one, but if the current C is a space and the last C was also a space. Right, it activated thinking mode. Maybe I think we're getting bogged down with this problem is because the reason we're getting bogged down with this is to do the actual to get the actual final list of numbers or final digits of the number we should create. We're just doing a couple of transposes. Maybe that's what I think. That's what is screwing us, right? Now I call it a grid. Delete that. And then GHC part 2. Just 1, 2, 3, 3, 2, 8. Nothing, just 5, 1. Just 6, 1. Okay. So we need to add this back. So instead of calling to int, we're gonna call basically just parse. I guess this is the the new parse number line, right? Instead of that, it's this. Parse number line, we need this back. And then following the type errors, we need to update the types accordingly. GHC, because we're now using a maybe instead. Nice. So the first column, let's look at this, it's just 1 and then followed by nothings, and then the second one is 2 4 followed by nothing, 2 4 followed by nothing, and then 3 5 6, 3 5 6, but the number we should finally create, oh, this should be okay. So 3 5 6, and then here just 3 6 9, and then just 2 4 8, and then just 8 and nothing, and then nothing, just 3 2, and then just 5 8, just 5 8 1, and 1 7 5 5 3 2 6 2 3 6 2 3 4 3 1 4 3 1. Nothing, just 4. Okay, so I think once we have this, we can be sure that it is correct, and we can add back the, now we just need to update the combine to ignore GHC. Yeah, combine digits is complaining because it should be receiving a maybe. a maybe int list now. So here we can say can do this by we can turn it into without before reversing it we need to maybe map, right? We used a maybe map before. Maybe map will accept a function that will accept a list that's basically I guess let's go to Google everything. Then we need to search for a maybe a to a list of a. So it's gonna be maybes, no, take while just no until just while just cat maybes. Yeah, and then cat maybes, then reverse it, then map over, and then it's summed up. I think that's what we want to do. JC. It's saying the expected. Oh, okay. So part numbers will now return a. What did we used to do actually before on part one? Part one return the other in a part one dot hs. Same here. It's gonna return an extra list of numbers, double extra list of numbers, and then let's see this part 2. So we're gonna multiply 124 and 356 and then 369 to 48 and 8 and then 32 581 and 175. The good thing is the operations are like what was the mathematical formula? You can like switch them around, so combinations, yeah. So it's like multiplication, it doesn't matter. So let's just apply it, let's just run it. So we need to do 2 columns and solution dot. Let's hope this is correct. Doesn't seem correct. No, it's not. What? Because okay, let's actually write this down. Isn't this correct? Let's actually look at the columns. Maybe that's why something is going wrong. Look at this, yep. Oh. There are some extra numbers in here. I don't know where they came from. How are we converting them to columns again? We transpose the numbers. No, we don't want. Nah, that's not it. Yeah, I think transposing was only necessary for the first one. So multiply 1, 2, 1, 24 and 356. Yeah, I think that was the problem. We were solution dot. Let's hope it's correct now. Okay, run it over the input. እንዳትናንተ ነው ብቻ በዋናው በፋይናል አውትፑቱ አልሰራም እንዳይለን እንጂ that's the worst thing that could happen. ኤግዛምፕሉ ባይሰራልኝ ይሻላል. Oh no, your answer is too low. I think maybe let's make sure let me just make sure that the parse groups function works correctly. Groups. We checked that it works correctly for the example, but let's check it for a single line from that. This is the worst thing that could happen. Okay, let's check it for this line, and then let me give it this. Let's say GHC or okay. Oh, this is parse number line now. Parse number line. It starts with 744 and it should end with just 299. Okay, why else would it be failing then? Did we modify our input? You can still get your input. Save. Maybe we accidentally messed up our input while we were messing around. Override the input. For the example, it's working correctly. Let's go to parse input to column and then solution GHC. Of course, we need the input GHC. But okay, the sum was correct, but were the individual answers correct? Eight, 5, 4, 4, 6, 2, 5, 32, 3, 2, 5, 3, 2, 5, 3, 6, 0, 0, 3, 2, 5, 3, 6, 0, 0, and then 10, 58, 10, 58. But when we run it for the input, let's do GHC. No, sum them up and give me the final number. We got this number and we got told that's not the right answer. Your answer is too low. Okay, we got a too low at least. So let's save that and say too low. Too low. Why is that too low? I don't know. I'm not sure about this. Could there be a bug in here in the okay, I think maybe there are digits, for example, is no longer being used, so we can remove this, and then repeating is also not being used. JHC, yep, it's not being used, so we can remove that. Let's go back here. Let's look at the warnings that were generated by the compiler. Save that. Go down here. It's saying you can use map once, found, map transpose this, why not map combine digits dot transpose. Wait a minute, what? Found, map combine digits, and then map transpose this map. Why not just do map combine digits dot transpose? Okay, transpose, then we can remove this map. Okay, that's interesting. And then there are unnecessary parentheses here. Here we can just remove the nothings and just look at the just values. Yeah, but we're using Haskell today, but we got into that trouble where we got this error message. We saw this thing. The example actually ይሰራል መልሱ ግን it doesn't work for the main puzzle input, but the example ይሰራል. I'm getting this number, but the final output I'm getting is not correct. Or let me just move this back. Yeah, so I'm just trying to go over it to find the bug. How did we solve it yesterday, by the way? I think we found out that our approach was incorrect, and we rewrote the whole thing. Or what is this asking, for example? What's the grand total found by adding together all the answers to the individual problems? Okay, that's correct. We're still getting the same number even after doing that. Let's do that. Still the same number. And let's try the example. GHC. The only thing, so this parse number line was generated by GPT, so that's why I think that's probably where the bug is. Probably where the bug is. Okay, 326. And then what the fuck? Okay, that's correct. Where are we making some incorrect assumptions? There might be a place where we're making incorrect assumption. So I think maybe let's call I have one idea. So maybe let's call dot trim before we call parse combinations. No, I mean before we, yeah, here. What if we call what if we just do list, or we can do like map trim, something like that. Is there a string dot trim? There's no string dot trim. I'm just going to Google. Nope. Split string dot split. Or not split, but trim. There is a string dot trim. Don't need this, don't need that. Yeah, I don't know what's happening. Oh, it has hard-coded it to split by 3. This is wrong. Okay, I just saw the error. Splitting at the 3rd position won't work. The sequence of digits can have different widths. Yeah. It did a split at 3, so it's going every single time. It's checking for the split by 3 and then checking for if it starts with space, then it adds the nulls, I guess. This is checking for 0, an empty list. It's still doing chunks of 3. Oh, it's okay. This is the final output. Oh, okay. I'm wrong. Yeah, it's, I think, okay. It only does the chunking after the. Let's see. Then the trim bullshit. Just remove that. We're still on the example. No, the example isn't correct now. So let's do. No, nothing, just 6. That's wrong. I guess let's compile an example, a list of examples. So this should be think that I can tell the difference from, but oh, are you reading from the other chat? I'm reading from this one. What's your approach? Okay, I can explain it. Just give me a minute. Just give me a minute. Let me just compile this for 5, and then 6, 4 down, and then this will be 3, 8, 7, and then a 2, 3. Maybe does the current line not have enough information to be able to I think it had enough information. Just do this. Six, 9, 8, 2, 1, 5, 4. Because the underscore represents nothing. The I guess that's enough information for it. So okay, the approach is this. Let me just undo. Okay, so this is what we do. So we call the parse input function first. Parse input goes over, splits it into each line, and then we get the last line. We parse the last line into this parse operations line function that just creates. We created a custom type for it called an operation. So multiply and add. So if it sees a multiply, it creates a multiply. If it sees an add, it creates an add. So that's the first part. And then the second part is actually parsing the numbers. So we have a parse numbers function, and then that parse numbers function gets called here. So the you have to read it from the right to the left actually to understand this. So first we get a list of, so what, because we split it by the lines here, we will get a list of strings, and then for each line in that string we call this parse number line function. Parse number line will take a string, and then it will give us a list of integers, but the catch is the integers will they're not gonna be, it's not gonna be always an integer, it's gonna be an integer or nothing. Why do we need to represent that? Because we need to keep track of these the paddings that are in front of each number. So so that's like this one will just drop in, and then 1 will be the final number we'll get, or 2, 4. So because we need if we assume all of them, if we just parse them to a number, we will lose that. If we just parse 45 as the number 45, this 4 5 sequence of digits, if we parse it as 45, we will use the knowledge about where the padding was supposed to go, if it was on the left or if it was on the right. So that's why we're doing this. So that this will help us preserve that padding information, and then that will get called to transpose. So when we transpose it, so we have transposing is like a matrix operation, I think. Transpose, basically you're exchanging the columns for the rows. So transpose, so if you have like ABC and DF, the transpose of A is gonna be AD, BE, and CF as rows. So basically, this is how we parse them, right? So when we transpose, this is how we parse them. This is like our two-dimensional array is gonna be, the first array is gonna be 1 2 3 3 2 8 5 1 6 1 6 4, and then 4 5 6 4. That's a new row. But when we transpose it, we get the first row will be 1 2 3 4 5 and 6, and then 3 2 8 64 and 98. So that's what the transpose does. But like I said, we're parsing like 4 5 in this case will be nothing 4 5. After doing that transpose, we need to do a transpose again here. We need to map over each number and then transpose it, because the reason we're gonna have to do that is because we need to read the numbers from right to left, right? So the first number we read is not gonna be 1, it's gonna be 3 5 6 or 2 4, right? So this gives us basically, the first thing we need to do before, like, just forget about the ordering. Before we do that, we're gonna need to combine all the numbers at the zeros position, all the numbers at the first position, all the numbers at the third position. If you think about it, collecting all the numbers at the zeros column, that just means taking the first row of the transpose, and then taking the second row of the transpose. So we just need, in order to group them by like their 3 5 6 2 4, to group them into 3 5 6 2 4 and 1, we just need to do another transpose on the inner list of numbers we created. So that's why we do a transpose, and then finally we'll have a list of like 3 5 6 comma 2 4, like that's 3 5 6 is one single array, and then 2 4 is one single array, 1 is a single array. And then to be able to finally just add the numbers and stuff, we need to be able to combine them to like 356, a single number. So that's what combine digits does. So that's how it works. But the problem we're having now is this parse number line function that I talked about earlier, that just takes a line of, and like this number line, and then converts it into a list of segments of numbers where the empty position is specifically specified as a value of nothing. That's what's failing. Yeah. I don't think ChatGPT is gonna be able to pull it off, to be honest. It's okay, it's not doing any splits or drops in this one. Let's hope this does it. I want to be able to, I guess, should we just run it over our input, or should we, let's rip off the band-aid, let's run it over the, still the same number. We got an error for this number earlier, right? That's the same number. That's exactly the same number. Come on, what's going wrong? What's going wrong? This assumption is wrong. Take exactly 3 characters from one cell. Take exactly 3 characters from one cell is wrong. Sometimes we can have a two-digit number or a 3-digit number. It's ignoring it. I think this is probably the third time I've told it that. Or no, stop thinking. 2-digit number or a 3 or a 4-digit. I didn't see. Did you guys? I don't think I didn't see in the input. So there is 3 column numbers, 2 column numbers. I don't have, and the maximum I've seen is 4. I haven't seen 5 column numbers. Yeah, and then there are no single column numbers. Yeah, 2 is the minimum amount of columns. Maybe somewhere in the middle it could be 1, but oh, I think I just saw a single column number. I didn't. No, I didn't. How long have we been streaming? 4 hours. Holy shit! Another 4 hour stream. Ah. I think let's go back. So if we pattern to HS, so if we do something like this, take exactly, what if we do another case here? But this time we are gonna take or do something like this. And then let's take 4. How is that gonna work? And then let's add the and then let's add a case here. Let's add a case above it for taking 2 columns. And then map them into a cell. Yeah, let's run this over the example. I don't think this is gonna work because we should be checking if those are spaces or not. See? Okay, see? Yeah, it said pattern match is redundant. Okay, I guess it's gonna be reversed. So at first we're gonna try to take 4. If not, we're gonna try to take 3. If not, we're gonna try to take, right? And then it's saying pattern match is redundant because more. Why? In case, I guess I don't know why it's redundant, to be honest. Yeah, the example is way wrong now because we're not checking if these 3 numbers are. We need to do something like this. Actually, I think it just gave me an idea. It just gave me an idea. So if it's either can we do like a pattern? No, it's not gonna work, is it? Access is in this case. It's where is access being? How is just calling go? on the string go go is the string, and then what if we do like, what if we say 4 digits and then immediately followed by a number followed by a space? We just we just resolve all the types, the cases. So the cases, that's the 4, I guess the cases are going to be something like this. It's going to be digit 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 and then space digit. That's the first pattern, and then we will ignore this digit or add it back to the list so that we don't take away from the next code. And then the second case is going to be digit 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 and then space digit, right? And this is for when they're from the right side, and then this is okay, and then digit 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 digit. Yeah, and then the other case, I think this is okay, this is the lowest case, or and then these are all, I guess, optional. And I guess not optional, but specifically there is a subvariant to all of them where there is nothing at the end, where there is nothing or there is a space at the end. Yeah, it just gets too complex. And then there is a subvariant for this one like this. For this one there is also like a variant of space digit digit digit, something like this. That's not gonna work, to be honest. I think I'm gonna call it quits. We're not gonna solve part 2 today. Yeah, the example code the input to know we're getting something wrong. Yeah, I think we should just leave it here, because, or maybe just let's look at the input. So we can know, how can we know the maximum width of a column? We can know that by, I think if we know the maximum I guess let's basically, what if we do this? Then let's take it out. The parser is in a columnar format like the following. Get the width from the longest sequence in the grid. it just, even though I keep telling it not to use 3, it just keeps on using 3. I think there is enough information in a single line, I think, to parse them correctly, right? Let's do something like this. Do this, okay. Create a go function, and let's try to pattern match all of the cases. It will be called with something like this, and then this will be so it will be maybe int. This is gonna be our current row, the current sequence of numbers we're looking at, and the second one is gonna be the final we're accumulating to, and then the final thing is gonna be the string, I guess. Right, so let's do go, and then let's just say underscore equals empty string, so that we know that the types are correct. One, two, I was talking about this is the correct number of, and then okay, and then it will return maybe int, right? Take the s to here. This is the first one, second one, third one. You can just say this is a string, I guess. That makes it better. String. It will return that. No, but in this case we can do that. Okay, so this is the pattern. Okay, this is the pattern. So when we first start, our row is gonna be empty. Do we need to check the state of our row? I don't think we need to check. We need to ever check it. So I think that's just there too, so that we're able to accumulate, or let's call it the current group, and this is the accumulator, and then this is the list. So are we allowed to do something like this, pattern match with a range of I guess like character, Haskell character range matching? So can I say anything from 0 to 9? Yeah, we can do that, but in a case expression. Yeah, something like this. B. We can say we can match for a specific character. We can check that the car they're passing in is specifically B, but can we check if it's okay? I guess we don't need to check that. We just need to check that if it's an empty. Okay, so let's say like I guess the base case is gonna be something like this, that we have a group and then we have an accumulator and then there is the final list, and then I guess if we are empty, we're gonna probably just do and then if we can do like if no, I guess we can just do the accumulator here. I don't know if there is anything will be left in the group, but we can do that. The second case will be we have something, or we see a sequence of list. We always check at least a sequence of 4 digits: A, B, C, and D, and then that's the tail. So depending on this, we can say we can see, so on for like cases like this one, it's gonna be 1 2 3 followed by an empty space. So 1 2 3 4 do 5 C D E. Let's say if something like this. And then we can say I don't think we even need to do the group, right? I don't think we even need that anymore. Just do this. Just forget the group. But we need a way to make sure that the list of this are not spaces. And so let's see how case expressions work. Where clauses, you can add where clauses to an expression. Okay. Haskell case statement. Not this. Isn't there a better Haskell wiki? Can we add conditions to function cards in Haskell? Nice, you can do that by doing this. So we can say forget about this. This is actually stupid. Is digit function that will return true or false if the given string all contains all what is it? Or I guess that's the first case. Should we do that like that? maybe we can do A B C D, but after we've taken 4 we don't, I think, given a string, if the string contains all digits. I guess we gotta say Haskell again. Forgot. It's gonna do Python by default. Haskell thing. This is gonna be a stupid way to do this, but yeah. And then I guess it has to be followed by. We don't actually care what is followed by, to be honest, right? We don't actually care. It could be, we just know that we saw a single space. We just care that we saw a single space. Because we know there are no like 5-digit numbers we're getting given. So it's all, yeah, this is it, I think. So, and then we can add this here. And then we can say is all digit, and then A, B, C, and D. If that is true, we're gonna append this to the, so we're gonna say just A, just B, just C, and just D. I guess we need to call digit to int. This is annoying. Let's create a, I guess to simplify this, let's do yes, and then it's gonna take a car, and then it's gonna return a maybe int just for yes x. We're gonna be just digit to int, or what does digit to int return? X. Let's just check. I think this one. Okay. Let's see. Type signature. Okay, that is correct then. Okay, in this case, I just want, actually this should just be a single yx thing, and then we can say this is y, and then we can say we can create n to be maybe of int, but this is gonna be nothing. So we can say here ya, yb, yc, yc, yt. Okay, I think that's it. I think that's it. But according to this is how you define it. Basically, just do that. Right, that should be correct. Then you can say const that into the accumulator. Okay, now we're gonna have to just keep on copy pasting. So our second case is gonna be something like this. That is followed by 2. Is this what we want actually? No, I don't think this is a valid case. So our other case is gonna be starting with a space instead of a. Starting with a space instead of, I guess we can do this to all of them. So if we start with a space and then we go BCD and then a space, but it actually depends when we see the so this is the only way a 4-digit number could be in our input. And then let's ignore that, and then let's go do this. Let's go do this. This is the only way, I think. That's the only way, because it can't start with a padding, or it can't start with a and then we need to this is the accumulator, and then we need to call go with this new data here, and then we need to call go with this new data, and then the current tail. And then let's talk about how a 3-digit number could be represented. A 3-digit number can be represented something like this. It could start with ABC, and then there could be a space, but this could be in a column of like 4-digit numbers, so we need to take in a D here, and just take the final number and just remove. We check that it's not part of the group. We check that it's a digit, but it's not part of the group. And then another case for an ABC, for a 3-digit number, will be something like this, but in this case we have to include the number we just took back to the tail. And then in this case, another way a 3-digit number can be represented is it's part of a 4-number group, and maybe in this case it started with a space. And I guess in this one, since it's always gonna be a 4-digit thing, we have to say N here. I don't know how we can keep should be something like this. It should be, all of them should be aligned to this. Okay, so it could end up that it started with a space, it's part of a 4-digit number, and then it receives a space, and then there could be another case where it ends at it's the final element in the actually another way that a 4-digit number can be represented is if it's something like this. It can be something like this, right? It doesn't have anything after it, but it's the last number. And then in that case, it's also a valid 4-digit number. And then in this case, it starts at it's just ABC and then a space, which is the normal case. Let's add a comment here, 4-digit number, and then that is a 3-digit number. It can be this space. And then let me just push that over. So let's look at the first case. It can be A followed by two, it should be ABC numbers, a space, and another digit. We make sure that all of them are so it should be 1 2 3 1 2 and then 1 2 1 2 3 1 2. So in this case, so in both cases, but it depends on where we're gonna put the nothing. But yeah, ABC at the end, one space, and then a digit. So we put a space, we put a nothing at the end, and then let's put a nothing at the beginning. Yep, these are the two cases. It's either have a single space at the end or a space in the front and another space at the end. And then, but these ones will have both duplicates of when the tail is empty. So oh, but that matches that one, right? So we have an empty here, but it didn't match. It only matched empty, empty, empty. We only matched the 3 digits, and we were at the end, and then there was no space after it. And for this case too, it could be that we are at the end, and this should be and then let's put an example here. I guess this is the space, then digit. This is no, this is digit, space digit, and then this one is digit. No space, digit, space digit. I guess we don't have to, so I think I can just do, I can now I'm gonna copy this and then since we have 2 examples now, follow this pattern and extrapolate the rest. Maybe will it notice the pattern? I'm not sure. I think these are all the possible ways that we can get a single digit number, a 3-digit number. and then a single space at the front, or nothing at the end. We're at the end of the list. Okay, let's talk about two digit numbers. This one is gonna be more complex. It's not gonna be more complex. It's gonna be exactly the same as this one, right? But it's gonna be two. No, it's not gonna be exactly the same. But oh, there could be a finite, like there could be a case in which we have something like this. We have like A, B, C. We have two spaces at the front because the max is yeah, but the other stuff is the same. That is not the pattern. The pattern could be at the start or the end. But I guess we didn't give it enough information to know. And we also need an example here where we have two spaces and then a digit. I guess this one's correct. Could have something like this though. Another case, but that was already. Could be another option. Could be 3, 2, 3, and then a 3, and then 3, 2, 3 space. But if there was 3, 2, 3, then right, then we're not checking for two spaces at the end. We change for one. Nah, this is not gonna work. I think the combinations are just way too many combinations. How much time have we? Yeah, it's probably, I'm probably just, this is not the wrong way of doing it. This is not gonna work because another case could be, it could just start as ABC, but so if it was part of a four group number, there could end up being like two spaces here. Before we get to the next number. Fuck, okay. This is could either be two spaces at the end and then a digit, or and then it could be. Actually, we don't need to check for cases where it's at the end, do we? We don't need to check for them. Because the recursion will handle them, I think. Let's remove those. I think there is no, we shouldn't check for cases where we are at the end. We should just do one, probably. Right? Why are we checking those? If there is a space at the end, it won't match the first one, but we should just do, I guess they are important, but we are adding back the D we just the number we just parsed out. Maybe I'm just gonna before writing them down, I'm just gonna write them down anonymously to just see how many patterns there are. So you have X, 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 X. That's the 4-digit number. And then you can have a and then you can have a X underscore, and then you can have dun. You can have a dun. And then there can be a da and da. This is just for the for a 4-column situation. There could be a situation in which where we have 1, 2, 3, 4, 5, 6, 7. So for a 4-column situation, we have seven types of configurations. So there could be like a number filling all the positions, or the first position could be empty, and then we can have 3 numbers, and then the last portion can be empty, and then we can have 4 numbers, and then yeah, and then for a 3-number group, the pattern will be and then there is the first one is empty, the last one is empty, and then the first 2 are empty, the last 2 are empty, and then that's it. So 1, 2, 3, 4, 5, 6, 7, and then for this one 1, 2, 3, 4, 5, and then for the case for the 2, there is X, then I'll just underscore X, and then X underscore, right? 1, 2, 3. These are but the individual groups. So in order to add them into a group, we need to know if they are followed by, all of them will have a variation of followed by an empty or followed by a space. But that condition for all of them is the same, right? That condition is gonna be the same for all of them. So we need to have a something that checks the tail. So for each one we check the tail if the length of, so for each one we check the tail if tail length. We don't need to do that, I guess. The recursion handle, we don't need to do, I think we don't need to do that. But what we need to do is given these positions, right, add them to the accumulator, then call it with the tail of the next one. But we do need to remove the if there is a space, we do need to remove the space after it. But I don't know about the precedence. I guess it could be just the 4 ones, and then the 3 ones, and then the 2 ones. 7, 15 types of pattern matches. If we can have the same function be the case handler for all of them. So basically internally, and then we need to do case tail if there is a space in the tail, or if there is an empty. Depends on how, if we should call the recursive function or not. So there should be a nested where clause here. There should be a where clause here, and then it's gonna be called handle case, or I don't know, handle. I'm just gonna call it handle. I'm just gonna call it handle, and then it's gonna take a string. It's the first argument. Oh, I guess it's not. That's not the first argument. The first argument is the row we just created, maybe int, and then the string where the tail that got left over. Let's do this. I guess I can do that. That's the row, and then that's the. Do we need another thing? It's like a mutually recursive kind of function. So, and then it will handle is gonna return a maybe in it, if I think I remember correctly, so that we can const it to the right. So the case is gonna be handle, and then this is the row, we don't care about that. Handle, this is the row, and then the first thing we need to pattern match on is we don't have anything, the string is empty. I guess we also need the accumulator then. Maybe int accumulator, and then call, just return the accumulator, I guess. Got the row, the current row. If there is a head, if there is a space, and then there is a tail, this will be the other case. This will be the other case. Here we did row, we're gonna say row. The row should be already part of the accumulator. We shouldn't really care about the row here. It should be, we should add that before we call this. We should call this it's gonna return the accumulator. this will be the accumulator plus plus go and then accumulator and the current tail. That's it, I think. And then here we will call bundle. Then we don't need to check for an empty string at the end of it. We just need to check that all of them are digits. We know that the next thing will be a space if we do that, once we do that. So it's gonna be handle, and then the new accumulator we're gonna pass into that is it already has the current row. Okay, and then this case is gonna be empty string. For this case we just check if BCD is a, and then we do a no here, right? Just be like that. Then if there is a okay, and then this will be an A again. But now there is a space here. It will be A comma B comma C, and then this will be a yes A, but then there will be a no here. What the third? Okay, and then now for the case with the first two letters are, the first two are empty. In this case it will just be C, D, and it will be a no, C, D, yep. This case will be back to A space B space, but these ones are spaces, and then this is A comma B, Y, A, Y, B, nope, and then a space, nope, and then a space. Now we're down to the single case. So if it's let's do that, let's do this one is I think the one with the most minimal changes. And then if it's something like this followed by 3 spaces, right, 3 spaces and just D, and then we can say bam, we can say bum 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 bum. No space. Continuously. Yep. And then we have a case where something like this happens. So instead of this, oh no, I think, yeah, instead of this should be like this. Then it's all empty strings except the first one. Okay, this seems correct. Yep. Okay, these are all the 7 cases, and then now let's cover the 3 cases. Hopefully from now on it will just be, because just the editing won't take that much long, so it's just this, but without the first position. Let's check it out. Oh no, if we're gonna take a position, just take it out the last one. It's just something like that, and then it can be then we don't have yep, we don't have that. Actually, space time, and then here it's always a no. It will be ABC, and then the last position will always be no. And then let's do the first one is empty. It will be state. And then the last one is empty. Okay. And in the case where there are two spaces at the front, A, B, C, okay, just don't, yeah, there are 2 spaces at the front, so let's do that, be something like this. And then we're just gonna take for C and push that out, and then it's gonna be a no. It's gonna be out C. It's gonna be out. It's gonna be out. Similar to this one. guess all of them are not that convenient. Let's do this one. One, two, three, four, five. 1, 2, 3, 4, 5. 5. Okay, that's the 6 ones. Okay, and now for the 2 element position row columns. You can remove this. Then this will have only 3 possibilities. This is the first one, where they only take up need to A, B, and then no. And then this one, it will either start with this, and then other one is gonna be this. Hopefully I think this covers all of the possibilities. This will be B, A. We're going character by character, just comparing everything, so I think this should be correct. It should just be B. Okay, I think these are all the cases, and then we can modify the last case to have it be down here. I can drop it down here, and then let's just basically ignore any other case, right? Oof, it's gonna be, and then let's try to actually ignore. Let's do this. Let's remove solution, and then let's call parse number line, and then let's call it with our examples. Let's see if this actually works, or did we just waste a bunch of time doing nothing. Okay, line 46, 46. Okay, I don't like that this was being highlighted. Actually, it was highlighted as a different thing. So let's call this, instead of handle, we can call this go with a tick. It's still causing an error. Why? Oh, okay. Maybe this need to be parenthesized. Is that what I'm saying? Oh yeah, they do need to be parenthesized. Okay. In that case, we can say go and then we can say is no, Haskell nested where block. Be why is that a parse error? Parse error on input dash. Oh, I know why that's on parse error. Okay, you're right. It should be double columns here, and then yeah, okay, and then similarity issue here with not being parenthesized. Okay, now let's look at the individual codes. What is it complaining about? Is all digit variable is all digit. Okay, is all digit imported from. Oh, we defined is all digits. Oh no, is all digit. Okay, is all digits. Okay. Another issue was suggested fix perhaps use go. I thought we had defined it so that we can use it. Isn't that our where clause? Yeah, intermediate. You can create a step here, and then you can combine them down up there. I think we did the same. Variable not in scope. Go with a suggested perhaps use go. I think maybe because you can look at it and the pattern is exactly the same. Maybe we don't need to define an inner function after all. Maybe it's just this. Right, and then this, and then that. And then we can forgot to say it in here. Illegal term label use of the type variable TL boundary in the second argument of Go, namely TL in the Why? You can call it raised at once. It's not the name, right? Illegal term label use of the type variable rest. Actually, we need that fallback case, right? So it's gonna be accumulator, and then this. Oh, I know what's wrong. Okay. Tail. Without this, will it complain saying it doesn't cover all position, all possibilities? Oh, it doesn't. Okay. Okay. Started with nothing, just 6, 4, nothing, just 5, 1, nothing. I guess we need to reverse it at the end. Reverse. That's why it's getting kind of confusing. Okay, now this is correct. Just 1, 2, 3, nothing. Just 3, 2, 8, nothing. Just 5, 1, nothing, and just 6, 4, nothing. Okay. So now we can use it. Print. So solution to columns of parse input of the input. Whoa, that's no, I guess that's a big number, but that's okay. Oh, I thought we were running the example. Okay, we are running it on the input. This could be correct, but I don't know. Yeah, it's not correct. 1205. Let's see what we have after calling two columns. GHC part 2. We have 124, 30, 124, 356, and then a 0 for some reason. Why do we have a 0? And then we have 3, 2, 6, 9, 8, 4, 8. I guess it's not parsing them correctly. This is wrong. Yeah, these are wrong. Okay, so let's revert back and see. I think another thing I'll try, but before doing that, I want to see all of the numbers. I want to see this. That's the second example. This is the second example. That was the first. No, this one is actually more complex. We might catch more problems with this one. With this. So this is nothing, just 4, 5, and nothing. Okay, but maybe should I do that? Nothing, just 6 4, nothing, nothing 3. Oh, this is wrong. Okay, just 6 4 nothing, and then this ended up becoming, because there was a space at the end of it, and that should have been caught by 6 4 space, so it should have been caught by a b space. But here what happened is 6 4 nothing parsed correctly, but after that it became, could it be this? It became 3 8 because the first space, okay, this space, the last space got parsed out, we parsed that out, 6 4 space, so this would be removed by a b space, and then we checked both of them are integers, so we created this object and then we called it with the tail. At this point the tail has this space in front of it. Or how many spaces are there? One. Are there 2 spaces, or how many spaces are there? I think there are only just 2 spaces. So the first space I think will be, oh, what if it had matched with the other one. So we have to, let's do this. I think we tried this earlier, but trace printing didn't work correctly for us. Let's do that. GHC. So we never, this tail call never gets called. What if we do that here? Trace final. Okay, we know. Okay, what? This is never being called. This is never being called. I thought it will be called every single time. Every single time we're at the end. So let's start with this, I guess. So we're gonna start with empty string for 5, and then another empty string. There are no. So for all the cases that start with an empty string, okay. It might be. I think that we need to. Our order needs to be very very accurate. So this one I think should pattern much before the other one. So as this one, and I think that's how you do it. 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 And I think that's how you So all of the ones that start with space, underscore, 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 and underscore, underscore, underscore. So all of this should be the first ones to be merged, and then we start from this, and then we go to this, and then this should be the last one. Like we can see, like the space is forming a diagonal here. We want that to be the case for all of them. So it's gonna be for that it's gonna be, oh, I guess this one should actually be inverted, right? This should be the first one, this should be the second one, the one with the most spaces should be the first one. Yeah, I think this is the one with the most spaces, and then that's the second one, and then that's the last one, and then for this one as well should be like this, because the other patterns might match before. Hey, is it still wrong? Nothing, just 4 5, nothing, just 6 4, and then nothing, nothing, just 3 8. How can we know which one was matched with? So I think maybe let me do this. So I expect this 6 4 to have matched with this one, A, B, and then empty. So let's just, I'm gonna remove the nothing from this one. So if this is true, no. Nah, I think I know why. Okay, so this should be, if you actually see the parsing, it's actually incorrect. The first nothing should be, yeah, the first value should be, even for the first, okay, this one is correct. It should start with a empty, but this one is incorrect. It should start with a 6. Why is that? Because let's go over this. We parsed this out, and then we created this correct with the BC, so it matched with this, and then created the correct value. But okay, so now we've removed these 3 digits, and then this is the tail, and then when we call the tail, yeah, that's why I had it be a separate function. If we don't have it be a separate function, it will mess up with our recursion logic. It will mess up with our recursion logic if we don't have it be a separate function. It will, no, the pattern laundry will mess up with the pattern laundry. Correct. But why didn't it like it? Why was it complaining about that? Let's say, instead of using go, use go dot, and then this one GHC, and then this indent this GHC, and then maybe this needs to move up to here. Don't make any sense. Let's say a Haskell mutual recursion. How do you do? I guess, okay, they can both be at the same level. Oh, okay. So here we need to add a handler go. If we didn't match any other thing, just return the accumulator. Oh, go. Okay, this is not exhaustive. Thought it would be. Do that then. Okay, now this one parsed correctly, but after 6.4 964 got parsed correctly. Let's say here I want to actually trace show the tail exiting and accumulator. So okay, after 6.4 gets parsed, we will have taken out 6.4 6.4 is parsed by this a comma b comma nothing, or it could have been parsed by the other one actually. What if it got parsed by this? Because it does match this actually. If you think about it, it does match this sequence of numbers. I think it did get matched by that because. So I guess we're gonna be taking the order. If we change the order, it's not gonna work for numbers with. That's not gonna work. It will simply, if the new example, the example will work for us if we did this, if we made this the highest priority. So it will be just 6.4 and then 3.87 nothing, which is correct. 3.87 nothing. Yeah, that's correct. But I think that will not work. That will not work. It will create trouble, especially for the final input. Yeah, this will not work. Yeah, it will just mess up with the order. So we need to know if we're actually when we're matching, we need to know if we are in the middle of a sequence or not. So we need to come up with a check here. What's called is followed. I guess let's call this is group, or I don't know, because we need to know if there is another space after it or a space decimal after it. So for example, the way we can specify to not parse this is with this one. Is this one thinks it's parsing a for group, but in order to tell it that, I guess it expects at least a single space at the end of it, which technically these are 6, 4 and then a space. But for these ones, their tail should, because for these groups, the tail should immediately be an empty yeah, something like this, or this, or like something like, yeah, but we should be at the end of the list, or we can just have one space next to us. If that thing following that is a number, then we're using the incorrect pattern. So we need to do something like is something like that. Empty color tail. In this case, it's true. If it's an empty string, that's also true. For all other cases, it's false. Oh. Okay, nothing for 5, nothing for just 4, just 5, nothing, and then just 6, just 4, nothing, nothing, just 3, 8, 7, nothing, just 2, 3, nothing. 1. Okay, so let's do input and then parse input and then 2 columns and then so Ushan. Hopefully this will work. JHC, not on the input but the example, but that seems, oh, but I'm way too low, right? GHC part 2, yeah, it seems way too low. Okay, so now we can undo this, yeah, this is how it's supposed to be called, right? So let's do parse input and then print that, but parse input will now return parse numbers will now return early. Try to print this and see what's going on. Has call stack, what inputs, oh, okay, let's format this. Predict. One, 2, 3, nothing. 3, 2, 8, nothing. This is wrong, right? It should be nothing, and then just 5, just 5, 1, nothing. I guess that's what's supposed to be true. Let's go back here. What pattern was this? Then it ended up being correct, right? Oh, didn't make it up though. Okay, maybe, but we did, at the end of the day, we did get the correct numbers. Just 6, 4, just 1. So in this one, nothing, just 5, and then 6, 4, and then 3, 8, 7, and then 2, 3, and then 6, and then 9, 8, and then 2, 1, 5, and then 3, 1, 4. Whoa. Why is the number we got so small though in that case? Right, so we are asked to multiply 124 and 1, 2, 4, and 3, 5, 6. But all of them have a 0. So this means the multiply ones just get erased. I don't know why there is a 0 at the end, but in the inputs, do we get one of the numbers? Can they ever be 0? 0 space. No, they can't be, so we can just filter them out. But I don't really know why we would have a 0 in there. Maybe is it happening in 2 columns? Zip with and then column operations, and then column is just created with but let me double check. So it's 124 356 124 356. It's 8248 369 8248 369, and then it's 75 181 532, and then it's, where is it? No, that's wrong. There is no 532. 532. No 532. How did it end up with 532? And then let's see, 532. Oh, 5. This is 1, and then 2 4, and then 3 5 6. Okay, and then the last position is always nothing, so it ended up being it ended up being 0. Okay, and then this is 369, and then 248, and then 8, then 0, because the last position was always empty. And then okay, 532. Oh, because this one messed it up. We talked about this, right? I think I noticed this. Yeah, I think that one messed it up. 532, and then the next one become 186, 181. Okay, 181, and then 75. Okay. We noticed that what was this? So this one, so just 5 1 nothing. This should be nothing, just 5 1 nothing. Okay, so there are a couple of positions where this could have been created. Okay, it could have been created here, AB. It could have been created here, but for all cases we check that it's either it's following we only know that if it's a group, if it's followed by a string. So will this one match? I don't think so, because we have A, B, but we don't have any two spaces at the end of it. We have this one. I think this is the one that got matched. Yeah, because basically we're just looking at AB, and then the tail has a, it's one of those that end with a space, so we considered it. No, this one. 6-4 is being parsed correctly actually. 5-1 is the issue. Okay, it's one of those that start with a space, I think. Let's do that. Let's go to the it should have matched with this. All the other ones are correct, right? We verified that. So I think we need to be stricter about the is group check here. We need to, in addition to knowing that it's a space, it can only be a space followed by an empty. This is valid, right? If the end is just this is a group. And otherwise it's false. But if it's something that's followed by another head, and you have a tail here, something we don't care about. In this case, I think head has to be is digit. Right, I think that's it. If it's not a digit, if it's a space, this is not a group. This is not your group. You should be matching with something other than this. So I think that's it. So let's update this, save this, and parse inputs, and we just, I guess, log the input. GHC. It's still ending up as 532. How are we parsing it earlier? We had disabled this stuff. and then just call this, call that. So if it takes, it should fail, and then one, two, three, 3, 2, 8, 5, 1 at the first position again. Actually, it might be because 3 to 8 is taking all of its spaces, because there are 2 spaces at the end of it. So look at this situation. So there is a number, and then it checks if it's, so it may that it will first pattern match to this, right? 3 numbers followed by a space, and then it checks, it goes into its group, and then its group says if it's ahead, and then the next one is also a space. If you're 2 spaces in, I guess what I should be doing is maybe something like this. If you're 2 spaces in, but that doesn't matter. If the next one is a digit, then yes, this is a group. The next thing after your space is a digit, yes, this is a group. So what happens is, yeah, we've already taken this space, and then it checks after this space, and then that's a number. So this ends up being true, right? And then this takes all of the spaces from the next person. Oh no, we won't take all of its spaces. We just check that. We just use that to check, but we will only take this space, and then the next call would look like this. Three, 2, 8, and then space. What are we doing here? And then that gets called, and then okay, that finishes taking the spaces, and then when it calls the next function, it says this, and then it takes a wait space, and then basically this one parses up to here. Yeah. How do we know what's the check here? What's the actual check here? I don't actually know if there is, we can add a check for this, right? So A, B, C, and then a space. A, B, C, and then a space, and then followed by a tail. Is group. This will only cause a problem if the next one has less digits than the current one. Is that right? think that's right. Nah, I don't know. Like, how can if we knew? I think I was worried about this. Maybe we need to know the max. We can't. We maybe we don't have we don't actually have enough information from the from being on the first row. Right? We don't. Maybe we don't have enough information. One chunk followed by the other chunk. Okay. If I just move this. Wait, which one should it be matching against? This should be matching against this, right? But that has that's like a low probability. That's not gonna fail. That's not gonna succeed. I don't know if there's a conditional we can use. Maybe we need to keep track of something. Keep track of the number of columns or the number of items we've added to the current row. And the current accumulator length is that won't give us any information. Maybe we shouldn't take away the tail here, and then maybe all of them should just call it maybe. I don't know if that will work, but that would be annoying to do. I'm thinking if maybe all of them did go or if all of them did select go accumulator and then space. All of them took out their all of their spaces instead, and then when we call it here, we prepend a space to it. Or I guess we can do this. No, I guess that creates a problem. Okay, so this should be something like this then. Go here, create a space. Do that, never do that. ኧረ በለው ከ6 ሰዓት በላይ ሆኗል። አይ ቲንክ በቃ ይበቃናል ዛሬ። It's not, I'm not gonna solve it. I'm not gonna solve part 2. There's no way. There's no way we're gonna solve part 2. Yeah, it's not gonna, this doesn't work. I think, oh fuck. I think I came up with an idea. So if you're saying this, if you're like looking at this, look at the operators. We should always, like, a new group, we know that a new group always starts at the what do I call it, the index of the operator. So if we somehow keep track of the index in this thing, and then the only way a group like this is group should merge if the tail dot length, I guess. So for example, this would be at index 0, this would be at, let's say, 1 2 3 4 5 at index 5, and then after we've removed this, the only way this the current then for this one also we should check that the tail length is gonna be the line index minus there needs to be an operator that exists at that index. Or we can, I think I just found out like a way to do it. You can just use the operator indexes and then just call freaking split at again and again. The operators really always just start. I'm ignoring the position of the operators. But parse operations line. How am I doing it? Parse operations line. Where is it? Here it is. So we're just doing a map maybe, and then a string dot words, and then just find the. Yeah, that's wrong. So we should be doing. String map. We have map with index, right? So we're gonna have our own custom map with index here, and then map with index into operation return, say. Okay, here we need to do it's gonna take a car, and it's gonna return a car, and then it's car. Maybe this one will now need to accept a then here we're done. map with index. It's gonna be here we'll say map with index stupid. Okay, so map with index and then x index comma car. So what we need to do is do, I guess, index comma or I guess yeah, that's correct. And then, but this is a different operation than how we're using how we're using the, no, it's the same thing. So we just need to know what the position is. The same thing. So let's update our operation type maybe. Let's upgrade our operation type to be a and then int. No, that's confusing. Let's just do this. Let's just do it's an int. I'm gonna say cut maybe to only filter out the just values, but now we're mapping with the index, so we'll know the index. But here I want to be able to return something like this. So the operation list, I want that to be a separate thing, and then I want the list of ints to be a separate thing because they're gonna be used for different purpose. GHC line 29. Yep, there is no need for a comma here. GHC. Okay. 96. Yep. So cut maybe that operation like this. GHC. Yeah, let's do something like this here. So operations and indexes, and then that will be this, and then in operators. I guess I'll call it operations. Okay. Oh yeah, okay, so this is now returning a list of operation comma int, right? JC. Now this is returning, it should be returning maybe, and then the order will be int comma operation. See, but yeah, this is correct, but this causes problem. So if we prepend cat maybes to the front of this, and then do GHC actual int car maybe int. So I guess this will be this now because we removed GHC. Okay, nice, this is working correctly. And then Haskell function to split a like what's I guess it's gonna try to create it, but I just want to know the name. But Haskell function to split a list of tuples into two lists. Unzip, or I think, yeah, unzip, yeah. So if we call unzip on this, this will be something like this. Hope so. In that case, this is the indexes. and this is the operations. See, and then I guess let's rename this because I don't think it likes that we're shadowing it. Yeah, I didn't. Okay, now we have the indexes, so to parse numbers we can pass the indexes and then here take the indexes and pass them along to each parse with number line call indexes. Now how will we use this? That's the question. But parse number line indexes, yeah, I received that variable not in scope. Oh, we're not taking it out, that's why. Indexes JC. Yep. Okay, now how will we use this? I don't think we need this. Yeah, hey, pattern much go parse around የሚያስፈልገን አይመስለኝም. I think we can just go over the list looking at each. I guess this will the position ጥሩ ነው, like to know when a group starts, but yeah, that's not gonna help us really. It's not gonna really help us. So how do we know that's at the start? Okay, even I think I need to do a little bit of maths here. So we have the length of the tail, we can compute that. So length, and then there was a chunk here, the last index position we have is this, and then the next index position is gonna start at here. Index. In each group we can say, after removing one space, we can say we need the length of the whole string first. Okay, we can do that by calling, so this is s, so s minus l should give us the, so if this was so let's say, well, let's look at this example. So we're gonna see if like 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So there is 14, the width is 14. When we are here 1 2 3 4 5 6 7, so we'll have 7. The tail of the tail of this group call is gonna be 7, right? And then what's the length of this? But we don't actually care. And then we know that this one starts at 0 1 2 3 4 5 6 let's try. So 1 and 2 3 4 5 6 7 8 9. Is that how many digits there are in front of this? No, 1 2 3 4 5 6 7, 8. I think 8. And then, but there's only one, so yeah, 8. So there are 6 there. 7, 8, 8. There are 8 numbers. So this is at the 7th position. So what we're gonna do is the and then what we're gonna say is digit. No, we're gonna say forget about this digit, but we're gonna say dun, dun, dun. Links links minus length of tail, length of s, I guess, and then this will just call this tail should be some kind of contents or elem. I think elem on indexes. That should be, there should be like it shouldn't be a random position, it should be an ending position of a see, right, and then it's log this. Oh, the parse input is basically failing. This is because this is always returning. This is always returning false. But what file is this? What are we running? We don't want to do all the transformations just yet, so this will now be a maybe, and then this will be maybe so around that as well. HC, and let's remove that HC. Okay, now let's add back this logic here, right? This should be no thing. Yes. Okay. Pretty print this. Then let's go back. Let's move this back in. Hopefully it will be correct now. Okay, just 1 2 3 nothing, 3 2 8 nothing, 5 1 nothing, yeah, and then 6 4 nothing, second matrix, nothing, just 4 5, nothing, just 6 4, nothing, nothing, and then just 3 8 7, nothing, just 2 3, nothing, nothing. Then the third one, nothing, nothing, 6, nothing, 9 8, nothing, nothing, 9 8, nothing, nothing, 2 1 5, nothing, 2 1 5, nothing, and then 3 1 4, nothing, 3 1 4, nothing. Okay, and then let's see where we are converting those maybes into an int. So that was actually causing problems. So let's do this, let's do that, let's do this, and then now should be this, and then this, GHC. There are still zeros at the end. Where is my pretty print this? So yeah, the numbers are correct. 124, 356, 369, 248, 8, 32, 581, 175, 623, 431, and 4. But there are zeros at the end. So that's happening because in combined digits we're doing something wrong. What does cat maybes do actually? I thought cat maybes would have given this would have filtered all the. What happens if we didn't do that? I guess because the type won't match. I guess the type won't match. I don't think it's combined digits. Combined digits is actually doing the correct thing. The problem is we're already returning combined. Okay, so I think let's only, for example here, let's only return I don't know if this will break it, but I don't think it will. Let's not return. I think we're always returning a four digit sequence, regardless of how long the actual input, how long the actual group we parse it with, right? And then for the 4 cases you can put 4 elements in there, but for the other ones don't do that. Okay, pretty print this. I think this is correct. Yep. Now we can do 2 columns and then two columns and then solution GHC. This seems correct. Now let's run it on our input. Hopefully this will be correct. I'm tired. Yeah. Finally. Holy shit, after 6 hours. Holy shit. I'm not gonna even touch this. I'm not gonna make it nice or anything. Just add it, commit. I think I should just sleep now. It's just way too annoying. It's never give up, I guess. ሶስት ጊዜ ነው አራት ጊዜ ስትሪሙን ዘጋዋለሁ እያልኩኝ ነበር ግን I guess we finally figured it out. I'm probably the last one today ከሰሩት let's see the leaderboard. Oh, I guess ኢዘዲን እና ጆሲፈስ እና ክራንዝ ናቸው የጨረሱት. Most other people didn't do that. በለው ግን finally እና I don't know, I think Haskell ሳይጠቅመኝ ቀርቶ አይደለም. Haskell was good. It actually was good. Let's do Haskell. እንደነ ኦካምን እንደነ ኢድሪስ ምናምን እያስቸገረኝ አልነበረም. አብዛኛዎቹ like ኮንሰፕታቸው የማውቃቸው functions like of course like something like this or a zip function ቅድም እንዳየነው or like that splits a tuple into two lists or a cat maybes function that filters out the just values from a list of maybes and that kind of functions ነበሩት. So yeah, of course, because it's the most popular one, it will have those things. Someone would have already added them to the standard library, but the other ones, Idris and the other functional programming languages we've tried till now, don't have them. Sure, update didn't have them. Then Haskell was good in terms of that. Let's keep this open and then let's go to GitHub, Pythons and advent of code. So yeah, እስካሁን እንዳለ functional programming language ነው የተጠቀምን ያለ ነው. I don't know if I think I'm getting tempted to just have this be like different types of like functional programming languages. Like I think we can do Elm tomorrow. What other like functional programming languages am I aware of? But yeah, we can do I think we can do 12 ቀኑን like አዲስ 12ቱንም ቀን በተለያየ ላንጉጅ ማድረግ እንችላለን. Yeah, so እዚህ ውስጥ ወድቀናል አሁን. We taught a bunch of cephalopods how to do maths. we had to discover it ourselves. But yeah, and then we're gonna go into some kind of, I think they're gonna ask us to group something into 3 buckets or something. Yeah, something like that. It seems like that, but I'm not sure. Let's go back here. See this list. Oh, you still working on it? Okay, I'm gonna well the solution is, what you're gonna need to do is this is what you should do. However you're parsing out these numbers, the first thing you should do is parse out this operator list one, right? የዚህን ኦፕሬተር ሊስት ፓርስ ካረክ በኋላ የእያንዳንዳቸው ኢንዴክሱን ታውቀዋለህ. Like you'll know the indexes, and then when you're parsing out the numbers, however you're doing it, iterating over the characters or dot split with the string መቼም አይሰራም, ግን I think I'll recommend iterating over the characters and then just only consider it a group or a valid number we should consider when you see an operator. And then okay, so that's the first part. That's how you should do the parsing. የፓርሲንግ ፖዚሽንን ስፕሊት ማድረጊያ ፖዚሽንን ማወቅ ያለብክ ከነዚህ የኦፕሬተሮቹ ኢንዴክስ ፖዚሽን ነው. That's the first part. The second part, how to do the like the rotations of like rotating this to be 3, 5, 6, 2, 4 and 1. When you split it, you should keep a nothing value next to them, like not don't just put like 4,5 in a list or just 6 on a list. You need to be aware of the padding also. So you can maybe prepend it with a bunch of nulls if you're doing Python or JavaScript corner. You can prepend it with a bunch of nulls or undefined, and then like you have to, even if you get a space character, you have to keep track of it. Like you don't have to, that's the first part. That's the second part. And then the final operations you need to perform to get the number is, I think I've talked about this earlier, but you just gotta transpose the matrix transformation. No, like so you do a nested loop and then get the index element from those. Just create a transpose the transpose function, the first thing you need to do is transpose the whole list so that 1, 2, 3, 4, 5, and 6 will be in the same row, right? And then for each one, after you've added the padding, this would be one row. 1, 2, 3 would be one row. 4, 5 would be one row, and then 6 would be one row, padded with their undefined values. And then when you do a transpose again, you'll have 3, 5, 6. A list with 3, 5, 6, 2, 4, and then 1. And then just string concatenate them and then parsing them, or anyway, like just convert those values into numbers. But the first part is operator based, like indexes. They'll use the indexes. Use the indexes from the operators. And then the second part is make sure you're padding them. Don't drop the values. Don't drop the spaces. You need to be aware of the padding. And then the third one is transpose, like rotate the shape, the list, and a couple of times to get the items in the correct order. That's what I would say. But yeah, I've just pushed my code, so you can check it out if you want. Yeah, you are. Don't give up. Yeah, peace, Becca. Ciao, ciao. Then thank you for being here, everyone. I'm gonna close the stream.